Hello there, and welcome to Life Beyond Seen, where curiosity gets cozy and science takes the scenic route to slumber. Tonight we're travelling somewhere most of us will never go, a place darker than midnight and heavier than any burden the human body could withstand. The Hadal zone. It's the deepest part of the ocean, the trenches carved into the seafloor where pressure builds until it becomes nearly unimaginable. Yet, in this seemingly impossible world, life has found a way to endure. Creatures exist there that look like fragile inventions of a dream, and they live every moment under crushing conditions that would flatten us in an instant. Before we sink into this strange world, I'd love to know, where are you listening from right now? Are you somewhere near the coast, where the sound of waves might already be familiar, or far inland where the idea of the ocean feels almost like a myth? If you feel this journey into the depths is a good way to relax after a long day, I'd be grateful if you gave the video a like and maybe subscribed. It helps this quiet little space drift out to others who might need a gentle escape. So, settle in, loosen your thoughts, and let's begin our slow descent. Because somewhere between the lapping surface and the blackest trenches lies the story of survival against pressure, cold, and eternal darkness. When you picture the ocean, what comes to mind first is probably a beach, a horizon. Maybe the surface rippling in sunlight. That's the part we know best. Most of our experiences with the sea stop at wading depth, or perhaps if you've been lucky enough to dive or snorkel, just a little deeper where fish dart among coral. But the ocean is far more than that. It stretches down thousands of meters, and at its deepest it carves trenches that plunge over 11,000 meters, deeper than Mount Everest is tall. These are the Hadal depths. They are named after Hades, the ancient Greek underworld, which feels appropriate because they're a realm out of reach, both foreboding and mysterious. The Hadal zone begins around 6,000 meters below the surface and continues downward into the deepest trenches. To reach it, you would first pass through the epipelagic, the sunlit surface waters, where life thrives on photosynthesis. Then you'd leave behind the light, sinking into the twilight and midnight zones where darkness takes over. But it's not until you cross that threshold into Hadal depth that the rules of survival change dramatically. Imagine the weight of a small car pressing on every inch of your body. That's just a fraction of the pressure felt at those depths. For every 10 meters of descent, pressure increases by about 1 atmosphere, the same as what you feel standing at sea level. At 6,000 meters, that's 600 atmospheres pressing in. At the bottom of the Mariana Trench, it's more than 1,000 atmospheres. To put that into perspective, that's the equivalent of several tons pushing down on something the size of a postage stamp. Yet, somehow, life persists. When scientists first began to explore these depths, many assumed nothing could survive there. It seemed impossible for cells, let alone entire organisms, to withstand such crushing conditions. And yet, when the first submersibles descended into trenches, they saw movement. Strange, ghostly shapes drifting in the beam of lights. Fish that had never been imagined. Amphipods the size of a human hand scuttling across the seafloor. Microbes living in the sediment, quietly breaking down material that had fallen from far above. The Hadal zone is not lifeless. It is simply hidden, its residents perfectly adapted to one of the harshest environments on Earth. Thinking about this hidden world brings up another question. How often do we mistake what we cannot see for nothing at all? For centuries, the deep sea was thought of as barren, a featureless void where sunlight could not reach. But the more we look, the more we find. It's a reminder that absence of evidence is not evidence of absence. Somewhere in the crushing dark, entire ecosystems flourish beyond our expectations. Just as time tricks us into thinking it moves faster or slower, depending on our attention, the ocean tricks us into believing its mysteries end where our eyes stop seeing. But they don't. They stretch on deeper and deeper, waiting to be uncovered. One of the most fascinating aspects of this world is how life has evolved to cope with a relentless pressure. For example, most animals cannot survive because their cell membranes would collapse. proteins would lose function and basic chemistry would fail. But Hadal creatures have special adaptations. Their membranes are infused with molecules that keep them flexible even under intense pressure. Their proteins are stabilized by unique compounds, allowing them to function where ours would break apart. Even their bodies are shaped differently, often softer, gelatinous, with fewer hard parts that could crack or shatter. To us they look strange, otherworldly, sometimes unsettling. To them, they are perfect. It is tempting to think of these animals as fragile, but that's only from our perspective. If you were to scoop up a Hadal snailfish, a creature that lives happily at depth over 8,000 meters, and bring it to the surface without special equipment, it would not survive. Its body is tuned precisely to high pressure, and without it, the chemistry keeping its cells stable unravels. We are the fragile ones in their world, unable to withstand even a fraction of their daily environment. They thrive where we could never step. But survival here isn't just about resisting pressure. Food is scarce in the Hadal zone. No sunlight reaches this deep, which means no photosynthesis, no plants or algae to form the base of the food web. Instead, everything depends on what drifts down from above. Marine snow, a gentle rain of tiny organic particles, dead plankton, and waste slowly sinking through the water column. Occasionally larger things fall, a fish carcass, a tree washed out to sea, and rarely, the most extravagant gift, a whale fall. When a whale dies and sinks to the bottom, its massive body becomes a feast that can sustain life for decades. Worms, scavengers, and microbes all gather to dismantle it piece by piece. In the Hadal trenches where resources are scarce, such an event is like winning a lottery. It is strange to think of creatures living their entire existence waiting for food to fall from above. But that is their reality. In a sense, the Hadal world is sustained by the surface, a constant connection between the bright shallows and the dark depths. Even here, life is not isolated. It is part of a chain stretching from the sunlight to the blackest trenches. Exploring the Hadal zone has been one of humanity's great challenges. The pressure destroys equipment. Submersibles must be engineered with extreme precision, their hulls shaped to resist collapse. Only a handful of people have ever visited the very bottom of the ocean. Among them, Jacques Picard and Don Walsh, who in 1960 piloted the bathyscaphe Trieste to the bottom of the Mariana Trench, and filmmaker James Cameron, who returned there in 2012. Each descent revealed more about this alien world, but still we have barely scratched the surface. To this day, most of the Hadal zone remains unexplored. It is one of the last frontiers on Earth, not because it is far away, but because it is so difficult to reach. And yet, the Hadal zone may hold answers to some of our deepest questions, about life's limits, about how organisms adapt, about whether something similar might exist on other worlds, beneath the icy oceans of Europa or Enceladus. Studying the creatures of the trenches doesn't just tell us about Earth, it tells us about possibility, that life can thrive in places that seem utterly inhospitable, that survival is not limited to the conditions we find comfortable. So tonight, as we sink deeper into this story, imagine the journey, leaving behind the familiar surface, watching the sunlight fade, feeling the weight build as we descend, past fish and jellyfish, past squid and sharks, down into the black where few have ever gone. Somewhere below, unseen, are creatures waiting in silence. They do not know of us, and we barely know of them. Yet our worlds are connected by the same ocean, the same planet, the same story of life. When we think of the ocean, the image that usually comes first is sunlight sparkling on the surface, waves rolling gently toward the shore, perhaps the sound of gulls circling overhead. That is the ocean we know with our own eyes, the part that feels familiar and friendly, the part where most life that we interact with exists. But this brightness only reaches so far. Sunlight, as powerful as it feels on our skin at the beach, is quickly swallowed by water. Within just a few dozen meters, the reds disappear. The deeper you go, the more colours vanish. At a few hundred metres, even the blues fade until nothing of the surface glow remains. Beyond that is a world that never sees daylight. It is here, in this endless shadow, that the descent truly begins. This is where the so-called twilight zone of the ocean gives way to complete darkness. For us, darkness is unsettling. Our vision is our primary way of knowing the world. To have it taken away feels like losing control, but in the deep, this darkness is permanent, unbroken, absolute. Imagine living in a place where day and night never alternate, where there is no sunrise, no moon, no stars, only blackness stretching in all directions. To us, it seems alien. To the creatures who dwell here, it is the only reality they have ever known. As we leave the last traces of sunlight behind, we enter what scientists call the midnight zone, the Baeth Pelagic. Here, between 1,000 and 4,000 metres, the ocean becomes a silent, cold expanse where pressure is already dozens to hundreds of times greater than at the surface. At these depths, no plant life can survive. Without light, photosynthesis is impossible, so the forests of kelp, the bright corals, the drifting algae, all are gone. What remains is an ecosystem built on what falls from above and what can be hunted in the dark. The creatures of this region have evolved extraordinary ways of coping. Some have eyes so large they seem almost exaggerated, tuned to catch the faintest trace of light, whether from a distant glow or the bioluminescence of other animals. Others abandon vision altogether, relying instead on sensitive skin, whisker-like structures, or chemical cues drifting through the water. Many generate their own light, tiny flashes or eerie lanterns that serve to lure prey, confuse predators, or signal to mates. To swim here is to drift among constellations of living stars, each flickering for reasons that to the animals themselves are as natural as breathing. The further down we go, the more surreal it becomes. This world is not barren, as once thought, but it is unfamiliar. Anglerfish with grotesque jaws drift through the black, their bodies shaped for ambush rather than speed. Squid stretch arms that seem impossibly long, trailing behind them like shadows. Shrimp and krill scatter at the first sign of disturbance, vanishing into the dark. These creatures are not monsters, though they appear strange to our eyes. They are solutions, answers written by evolution to the questions posed by their environment. What survives here survives, because it is perfectly matched to conditions that would overwhelm us instantly. As our imagined descent continues, pressure keeps building. Every 10 metres the weight of the ocean increases. To a human body, even 100 metres is dangerous without assistance. At 1,000, the crushing force would be unbearable, and yet these animals live without strain. They do not notice the pressure in the way we would. Their bodies are designed without air cavities, without delicate structures that collapse. Many are gelatinous, supported not by bones but by water itself, which cannot be compressed. In a way, they are as much part of the ocean as the water surrounding them. What is remarkable is how different the deep feels from the surface, and yet how connected it remains. Everything that happens above, the storms, the winds, the tides, reaches down in some form. Marine snow falls like a steady rain, drifting endlessly downward. These tiny flakes of organic matter invisible near the surface become lifelines in the deep. They settle on tentacles, slip into waiting mouths, or pile on the seafloor where other creatures scavenge. Each particle is the remnant of life from above, recycled into new life below. Occasionally, larger gifts arrive. A jellyfish dies, and its body drifts down, glowing faintly until it is consumed. A fish succumbs, sinking slowly into the black until scavengers tear it apart. And on rare occasions, a whale falls, its immense body a banquet for generations of deep dwellers. In a place where meals are scarce, these events are transformative. They bring abundance into scarcity, sudden life into a world of waiting. The deeper you travel, the more silence seems to close in. Sound moves differently through water, and in the deep it carries far. A crack or groan from a distant shift of rock, the low-frequency call of a whale travelling through the gloom, the faint stirring of water currents. These are the sounds of the abyss. They are not constant, but when they come, they echo like voices in a cathedral, vast and resonant, reminders that even in darkness the ocean is alive. Descending further, we approach the boundary that defines the Hadal zone itself. At around 6,000 metres, the midnight zone gives way to trenches, deep cuts in the seafloor that stretch far below the average depth of the ocean. It is here that the pressure becomes almost unthinkable. Here that life is tested in ways it is nowhere else on Earth. And here that some of the most remarkable adaptations exist. It is easy to imagine that as you sink this far, everything must become emptier, quieter, more lifeless. But in truth, the opposite can be true. Trench walls provide surfaces where sediment collects. Currents funnel material downward, concentrating food. Animals gather, not scattered randomly, but clustered where survival is possible. The result is not emptiness, but communities, ecosystems held together by shared dependence on what little drifts their way. We rarely think about this invisible realm when we look at the sea from above, yet it is there, shaping the planet, influencing carbon cycles, storing nutrients, regulating climate in ways we barely understand. The creatures who live here are not just curiosities. They are part of the Earth's system, hidden gears turning in the machinery that keeps everything else in balance. Without them, the ocean would not function in the same way. And without the ocean, life on land would be very different. The abyss is not simply a place of darkness. It is a place of connection. It links the shallow seas to the deep, the surface world to the hidden trenches. It is a reminder that no matter how far we go from the sun, no matter how strange the conditions become, life continues to find ways to endure. And so, as we press deeper into the very edges of what seems survivable, we carry with us the knowledge that even here, in a realm of shadows and silence, the story of life is still being written. As we move deeper still, the memory of sunlight is long gone, swallowed completely by layers of water that no ray can penetrate. The surface now feels like another world, distant and almost imaginary, as if it belonged to a different planet entirely. Here begins the midnight zone, the bathypelagic realm stretching from about 1,000 meters below the surface down to 4,000. To us, the name sounds mysterious and perhaps a little ominous, but to the creatures who live here, this is simply home. A place where light has no meaning, where day and night do not exist, where survival depends on senses beyond vision, and on adaptations that would seem impossible in any other context. The midnight zone is not empty. It is vast, yes, unimaginably vast, but not barren. In fact, this part of the ocean contains far more life than once believed. For centuries, scientists assumed that without sunlight there could be no life. After all, on land, everything ultimately depends on plants capturing energy from the sun. Without that energy, food chains collapse. But the ocean has its own rules. Here, food drifts down in a slow rain from the surface. Tiny particles, dead plankton, fragments of waste, all forming what is known as marine snow. Though it looks insignificant, this constant drizzle feeds an entire ecosystem. It settles on the backs of drifting jellyfish. It coats the arms of delicate sea cucumbers. It nourishes fish waiting in the dark. It may seem small, but it is enough to sustain life in a place where light itself cannot go. As we imagine ourselves here, it's important to picture the environment in all its details. The temperature is cold, close to freezing, but not quite. The water is still, with little current to disturb it. Pressure is immense, already 100 times greater than what we feel at the surface. To our bodies, it would be unbearable. To the inhabitants of this zone, it is simply the baseline of existence. Their forms are soft, flexible, and often gelatinous, lacking the rigid bones that would crack under strain. They are built to withstand what we cannot even imagine enduring. Some of the animals here are almost invisible, their bodies transparent to hide from predators and conserve energy. Others glow faintly, producing light through bioluminescence. This ability to generate light is one of the most extraordinary adaptations in nature. Tiny chemical reactions within specialized organs create flashes, patterns, or steady glows. For some species, this light is used to attract prey. A dangling lure shines in the blackness, tricking smaller creatures into approaching only to be swallowed whole. For others, light is a defense, a sudden burst that startles predators and buys precious seconds to escape. Still others use it to communicate, sending signals across the darkness that only their kind can interpret. Imagine living in a place where your entire language is written in glimmers of blue and green, where identity, warning, and desire are all expressed through light. One of the most iconic residents of this zone is the anglerfish, with its grotesque mouth and strange luminous lure. Its appearance is unsettling, with teeth like jagged glass and bodies shaped more for drifting than for speed. Yet for all their frightening looks, these fish are remarkably efficient. In a world where meals are rare, they have evolved jaws that can swallow prey nearly as large as themselves. They can go long periods without food, conserving energy until opportunity presents itself. The anglerfish may look monstrous to us, but to the deep sea, it is simply a survivor, honed by pressures of scarcity and darkness. Not all creatures here are predators. Some drift passively, waiting for particles to fall into their reach. Gelatinous zooplankton, translucent and delicate, form a drifting population that floats endlessly with the currents. Squid glide silently through the dark, some with bodies that stretch to astonishing lengths. Their eyes are adapted to sense the faintest traces of light, making them among the most sensitive organs in the animal kingdom. To imagine seeing the world as they do is to imagine perceiving what is nearly imperceptible, detecting the faintest glow of another organism kilometers away. The midnight zone also plays host to some of the largest migrations on Earth. Each night, countless creatures travel upward from these depths toward the surface to feed, returning before daylight can reveal them. This vertical migration, happening daily across the globe, may be the largest movement of biomass on the planet. Billions of animals rising and falling in a rhythm, a silent pulse connecting the dark with the light. It is easy to miss this when standing at the shore, but beneath the waves this pattern is as constant as tides and as ancient as life itself. To us, the idea of living without sunlight is nearly unthinkable. Our own biology is tied to it in so many ways, but in the midnight zone, life is not only possible, it is diverse. Each species is an experiment, a unique answer to the challenges of surviving here. Some are long and thread-like, drifting silently through the water. Some are squat and armoured, bristling with spines. Some seem almost playful, with glowing dots scattered across their bodies like living constellations. Each one tells a story of adaptation, of finding a way where none seem to exist. What makes the Midnight Zone so fascinating is not only the creatures that live here, but the sense of transition it represents. It is not yet the Hadal depths, not yet the trenches where pressure reaches its most extreme, but it is already a place beyond our comprehension. It prepares us for what comes next, for the even stranger, harsher world that lies below. If the ocean were a journey into other realms, the Midnight Zone would be the gateway, a threshold where light is lost, where sound carries strangely, where creatures drift like phantoms, and where we begin to realise just how vast and alien our own planet truly is. The further we descend, the more we must adjust our imagination. Think of a world where your sense of sight is nearly useless, where instead you live by vibrations, by faint chemical signals, by flashes of light. Think of a world where food is never abundant, where every opportunity must be seized, where energy is precious and nothing is wasted. Think of a world where every shape of life has been sculpted by relentless pressure, where fragility would mean death, and resilience comes in forms we barely recognize. This is not a fantasy. This is happening right now, all around us, in the oceans that cover most of our planet. In many ways, the Midnight Zone is a prelude, an overture before the deepest depths. It is strange enough to unsettle our expectations, but familiar enough that we can still imagine living there, at least in theory. We can design machines to visit, submersibles to record, instruments to measure. But below, in the Hadal trenches, even imagination begins to strain. Pressure grows so great that nearly all equipment must be redesigned. Human visits become rare and fleeting, and life itself becomes something almost unrecognizable. The Midnight Zone, then, is the reminder that we are only partway down. The descent has not ended, the journey continues. As the descent carries us past the last hints of the Midnight Zone, one element becomes impossible to ignore: pressure. We talk about it casually on the surface, the kind of pressure we feel from weather or when our ears pop on an airplane. But compared to what exists in the deep ocean, those sensations are so slight they might as well be nothing. The deeper you go, the heavier the water above becomes. Every 10 meters adds another atmosphere of pressure. At the surface, you feel one atmosphere pressing against your body, the weight of the air itself. That's about 14 pounds per square inch. At 100 meters down, the pressure is already 10 times greater than what you're used to. By the time you reach 1,000 meters, it's 100 atmospheres. And at the bottom of the Mariana Trench, nearly 11,000 meters deep, the pressure is more than 1,000 atmospheres. Imagine the weight of 50 jumbo jets stacked on top of you, pressing against every inch of your body. That is the environment of the Hadal Zone. For humans, this is instantly lethal. Our bodies are filled with air cavities, lungs, sinuses, ears that would collapse under such force. Even metal has limits. Submarines must be designed with thick, perfectly rounded hulls to resist implosion. A single weak point could mean disaster. It's no wonder that so few people have ever ventured into these depths, and even fewer have returned with stories. But for the creatures that call this world home, the pressure is not a burden. It is simply the reality they are built for. What makes pressure so devastating is not just its physical weight, but the way it interferes with biology. Proteins, the tiny molecular machines that keep cells running, can only fold and function in specific shapes. High pressure distorts these shapes, rendering them useless. Membranes, the thin boundaries that separate the inside of a cell from the outside world, are also vulnerable. Under pressure, they can stiffen and break. For most organisms, this is catastrophic. But in the Hadal Zone, evolution has found solutions. Some creatures produce special molecules called piezolites, compounds that stabilize proteins against pressure. Others have membranes rich in unsaturated fats, keeping them flexible when most would harden. These aren't just minor tweaks. They are fundamental redesigns of what it means to be alive, molecular armor that allows survival in an environment that would crush anything unprepared. To us, these adaptations seem extraordinary. To the animals themselves, they are invisible, simply the way life is. Consider the Hadal snailfish, a small, ghostly white creature discovered in the Mariana Trench. At first glance, it looks fragile, with a soft body and delicate fins. But this fish thrives at depths where pressure would destroy almost every other vertebrate. Its body has no swim bladder, the gas-filled organ that helps fish control buoyancy in shallower waters. A bladder would collapse instantly here. Instead, the snailfish's tissues are filled with a gelatinous substance that provides buoyancy without vulnerability. Its proteins are shielded by compounds like trimethylamine N-oxide, the same molecule that gives fish their distinctive smell. In shallow water, it is present in small amounts. In the snailfish, it is abundant, a natural defense against crushing force. Even microorganisms adapt in remarkable ways. Bacteria collected from trench sediments show enzymes that function perfectly under pressure, but fail when brought to the surface. Their entire chemistry depends on the deep. Remove them from it, and they die. They are not fragile in their world. They are specialists. Their existence challenges our assumptions about where life can or cannot thrive. For us, pressure is something to fear. For them, it is the foundation of stability. It shapes every part of their biology, guiding the course of evolution in directions we could not have predicted. Without pressure, they would not be what they are. In that sense, what feels impossible to us is ordinary to them. But the influence of pressure is not just biological, it also shapes the physical environment. In the trenches, rocks are compacted, sediments are dense, and water behaves differently. The chemical properties of seawater shift, affecting everything from how minerals dissolve to how gases are exchanged. Deep-sea chemistry is a world apart from the surface. Understanding it is crucial, not just for curiosity but for science. It helps us grasp the limits of Earth's systems and the possibilities of life elsewhere. When engineers design submersibles for these depths, they face the same challenge that evolution faced: how to resist collapse. The simplest solution is shape. A sphere distributes pressure evenly across its surface, making it the strongest possible design. That's why the passenger compartments of the Trieste, the deep-sea Challenger, and other trench diving craft were spheres. Walls had to be made of thick steel or specially engineered materials, with only the tiniest windows of fused quartz to allow a glimpse outside. Even then, the risk of failure is immense. Every bolt, every seam, every weld must be perfect. Pressure tolerates no mistakes. It is sobering to think that even with all our technology, the deep still holds power over us. A leak the size of a pinhole could cause instant destruction. Yet fragile-looking creatures drift there unharmed. Their survival is not brute strength but elegance, a quiet adjustment written into every molecule. They do not resist pressure, they are built from it. There is another way to think about this. On the surface, we often describe life as fragile. We talk about delicate ecosystems, about the fine balance of conditions that keep us alive. In the Hadal zone, fragility takes on a different meaning. Here, life has proven that what seems crushing and impossible can be a cradle of existence. The weight that would destroy us is the very thing that supports them. This reversal is one of the great lessons of the deep. Survival is not about resisting the environment, but about becoming inseparable from it. Pressure also affects how these ecosystems function over long time scales. Organic matter that sinks into trenches is compacted and buried more deeply than in shallower parts of the ocean. This process locks away carbon, storing it in sediments for millions of years. The trenches are not just habitats, they are vaults, shaping the planet's climate by regulating carbon storage. Without them, Earth's atmosphere might be very different. The crushing weight of water in this sense helps sustain the balance of life above. When we speak of pressure, it is easy to focus on its destructive power, but in the ocean, it is also creative. It builds environments that cannot exist anywhere else. It sculpts organisms into forms we would never have imagined. It creates stability in systems that seem chaotic. What appears to us as a barrier is, to life, an opportunity. It is remarkable to consider that pressure, which for us means danger and limitation, has become, for other forms of life, the very condition of survival. When you imagine the Hadal zone, imagine not a place of struggle against crushing force, but a place where that force is as ordinary as air is to us. Creatures swim effortlessly, drift calmly, and carry out their lives under conditions we would call impossible. To them it is simply Tuesday. As the descent continues, pressure will only rise, shaping everything we see. It is the quiet but relentless companion of the deep, pressing in from all sides, reminding us that the rules of survival are always written by the environment itself. And yet, as heavy as it is, pressure does not stop life. It becomes the stage on which life finds new ways to endure. Beyond the weight of the water pressing from all sides, there is another feature that defines the Hadal depths even more completely: darkness. On the surface, we are so accustomed to light that we hardly notice it until it is gone. We wake with the sun, work under lamps, glance at glowing screens, and even in the middle of the night, there is usually some small light creeping through windows or flickering from a device. Total darkness is rare in our lives. In the trenches of the ocean, it is permanent. No sunrise ever comes, no moonlight filters down, no faint star glow reaches through kilometres of water. Light simply cannot follow. Water is efficient at swallowing light. Within just a few metres of the surface, reds and oranges vanish. The deeper you go, the blues stretch thinner and thinner until they too disappear. At around 1,000 metres, sunlight is gone for good. From there down to the Hadal zone, no natural light from above exists. The trenches are cloaked in an eternal night that has lasted for millions of years and will last for millions more. To imagine this is to imagine a world without vision as we know it. A world where eyes, if they exist at all, must adapt to something entirely different, or else be abandoned altogether. But darkness here is not simply the absence of light. It is an environment that shapes every aspect of life. It dictates how creatures hunt, how they hide, how they communicate, and even how they find one another to reproduce. In the absence of the sun, evolution has written new solutions, each one a quiet answer to the problem of living in a place where seeing is no longer possible. Some creatures meet the darkness by creating their own light. Bioluminescence is one of the most common features of life in the deep sea. Tiny chemical reactions within specialized cells or organs produce glows of blue, green, or sometimes even red. For many animals, this light is used to lure prey. A small flash in the dark becomes irresistible to smaller creatures, which approach only to be swallowed whole. Others use it defensively, releasing sudden bursts of light to confuse predators, giving themselves a chance to escape. Some fish and squid use patterns of glowing spots across their bodies to signal to potential mates. A silent code written in sparks across an otherwise invisible canvas. In the complete black of the trenches, light becomes language, weapon, and disguise all at once. The forms this light takes are astonishing. Some fish dangle lures from their foreheads like living fishing rods, tipped with glowing bait. Others carry rows of lights along their sides, matching the faint glow from above so that when seen from below, they vanish against the last traces of dim light, filtering down from shallower depths. This camouflage, called counter-illumination, is one of nature's most clever tricks, erasing the outline of a body in the most literal sense. In the Hadal depths, where there is no surface glow left to match, some creatures still maintain these abilities, perhaps for use in the shallower regions they pass through, in migration, or perhaps because in the deep, light itself has taken on purposes beyond simple survival. Not every creature embraces light. Some abandon it completely. Their eyes shrink to useless dots or vanish entirely, replaced by heightened senses of touch, smell, and vibration. They feel the water move around them, detect chemical traces left by prey or mates, and navigate in ways we can hardly imagine. To us, darkness is blinding. To them, it is not blindness at all. It is a different kind of perception, one suited perfectly to their environment. What fascinates scientists is how this complete absence of sunlight has given rise to such variety. In a place where light cannot follow, life has found ways to bend the rules, to create light, to ignore it, or to reinvent senses altogether. It is not a limitation. It is simply the condition of living here. Darkness also changes the way the seafloor looks. Without light, colours lose all meaning. The sediments that line the trenches appear grey in submersible lamps, but to the creatures themselves, there is no colour at all. Shapes, shadows, and movements become the defining features of the landscape. Imagine standing on the floor of a trench, surrounded by walls that rise higher than the tallest mountains, yet unable to see them without artificial beams. To live here is to live without horizons, without the visual cues we rely on to orient ourselves. It is a world of formless space, defined not by sight, but by touch, taste, and sound. For humans, this darkness is unsettling, even frightening. When early explorers descended in the Trist in 1960, they described peering through the tiny window into blackness so complete it felt infinite. Only when the submersible's light swept across the seafloor did shapes emerge. Ghostly fish and strange invertebrates drifting out of nothing. Even today, when modern submersibles and remotely operated vehicles descend with powerful lamps, their beams only penetrate a short distance. Beyond that, blackness remains, pressing in on all sides, endless, unyielding. This raises an interesting question. Does darkness here mean the same thing it does to us? For the creatures of the Hadal zone, there is no contrast with light, no before and after. Their entire evolutionary history is written in the absence of sunlight. They have never known anything else. To them, this is not darkness. It is simply the world. Perhaps even the word itself is misplaced, a human attempt to describe what is, for them, ordinary. And yet we cannot help but frame it this way. To us, light is life. It gives us warmth, vision, growth. Without it, we imagine emptiness. The Hadal zone challenges that assumption. It shows us that life is not bound to the sun, that energy and survival can come from other sources, from chemical reactions, from falling organic matter, from sheer resilience. In a world where light cannot follow, life has written its own story, one that unfolds in silence, in patience, in adaptations so unusual they seem alien. The absence of light also invites us to think about possibility beyond Earth. Moons like Europa and Enceladus hide oceans beneath thick crusts of ice. Sunlight cannot reach those waters. If life exists there, it must live in conditions much like the Hadal trenches, in cold, dark, pressurized environments where light is irrelevant. Studying the trenches, then, is not just about understanding our own planet. It is about glimpsing what life might be like elsewhere, in oceans hidden beneath alien skies. In this way, the darkness of the Hadal zone is not simply absence, it is presence. It is the canvas on which life paints itself in unfamiliar ways, the condition that forces evolution to invent, to innovate, to surprise us. It is proof that life does not require what we think it does, that survival is more flexible, more inventive than we often allow ourselves to imagine. So when we speak of darkness absolute, it is not to describe emptiness, but to recognize that here, in the deepest waters, life has thrived without the thing we consider most essential. It has flourished in the absence of sunlight, creating ecosystems that depend not on light but on endurance, chemistry and patience. Where light cannot follow, life still does. And as we move deeper into this strange hidden world, the lessons of that resilience will only grow more extraordinary. If you could peel back the ocean's surface and drain away the water, what you would see is a planet shaped not only by mountains and plains, but by valleys that plunge deeper than the tallest peaks rise. These are the ocean trenches, the landscapes of the Hadal zone, immense scars in the seafloor carved by the slow movement of tectonic plates. To imagine them is to realise that Earth's geography is far stranger and more dramatic than we usually picture. On land, we marvel at Everest or the Himalayas, the Andes or the Rockies. But beneath the ocean, hidden from view, lie trenches that make even the tallest mountains seem small. The Mariana Trench, the deepest of them all, sinks to nearly 11,000 metres. If you were to place Mount Everest inside it, the mountain's peak would still be more than 2 kilometres below the surface of the water. These trenches form where one tectonic plate slides beneath another, a process called subduction. Over millions of years, the movement creates long, narrow depressions, arcs that stretch for thousands of kilometres. They are not neat cracks, but complex landscapes. Their walls are steep, their floors uneven, with ridges, hills, and smaller valleys within the greater depression. To descend into one is not like entering a simple hole. It is more like moving into a mountain range turned upside down, where slopes rise overhead instead of beneath your feet. The scale of these trenches is difficult to comprehend because we rarely see them directly. Maps flatten them, diagrams simplify them, but the reality is immense. Imagine flying over the Grand Canyon, already vast and breathtaking, and then realizing that an ocean trench is many times deeper and longer. The difference is that while the canyon is dry, the trench is filled with crushing water, hidden from human eyes except through instruments and brief glimpses from submersibles. The floor of a trench is not barren. Sediments collect there, washed down from higher regions of the ocean, funneled by currents, carried by gravity. Marine snow drifts into them endlessly, piling up over thousands of years. Organic material concentrates here more than in the open abyssal plains. That makes trenches important sinks for carbon, places where the chemistry of the planet is shaped on timescales far longer than human history. What seems like emptiness is in fact a vault, storing fragments of life and recycling them slowly, feeding the microbes and invertebrates that call this hidden landscape home. To explore a trench is to explore one of the last frontiers of Earth. Only a handful of human missions have reached the deepest points. Jacques Piccard and Don Walsh in the Trieste in 1960, James Cameron in 2012, and more recently, explorers like Victor Vescovo, who have piloted modern submersibles into several of the world's trenches. Each time, the reports are the same: steep walls vanishing into blackness, sediment stirred into clouds by the craft's presence, ghostly animals appearing briefly in the beams of lights, and then darkness closing in again. The impression is not of a static place, but of a landscape alive with mystery, shaped by forces too immense to fully grasp. What makes these valleys so fascinating is not only their depth, but their diversity. The Mariana is famous, but there are many others: the Tonga Trench, the Kermadec, the Philippine, the Puerto Rico, each with its own contours and conditions. Some stretch for thousands of kilometres, others are smaller but still unimaginably deep. Together they form a network of Hadal habitats across the planet, scattered like hidden worlds, each isolated by distance and depth, yet linked by the same processes of geology and ocean. Because these trenches are so deep and so separate, life in one may be distinct from life in another. Amphipods collected from the Mariana may differ from those in the Tonga. Snailfish from one trench may carry unique genetic adaptations not seen elsewhere. In this way, trenches act like islands, shaping evolution in isolation. Just as species on remote islands on land evolve into unique forms, so too do the creatures of the trenches, cut off from one another by vast expanses of ocean they cannot easily cross. Studying them is like studying parallel experiments, each one an answer to the question of survival under crushing pressure and eternal dark. The walls of trenches are dramatic environments in their own right. Steep slopes provide habitats for creatures that cling, burrow or scavenge. Currents funnel organic matter downward along these slopes, concentrating food in certain places. The geography creates microhabitats, small regions where conditions differ enough to shape what can live there. Some areas may be richer in nutrients, others more barren. Life arranges itself accordingly, just as plants and animals on a mountain arrange themselves by altitude and slope. What we know of these landscapes comes mostly from brief glimpses. Cameras lowered on cables record short videos before equipment must be hauled back to the surface. Submersibles make brief visits measured in hours, not days. Remote vehicles, though powerful, can only explore a fraction of the terrain. For every photograph we have of a trench floor, there are countless stretches still unseen. Maps, even the most advanced, are still coarse, leaving much of the detail hidden. In truth, we know more about the surface of Mars than we do about these valleys beneath our own seas. This lack of knowledge is part of their allure. To think that on our own planet, in the 21st century, there remain landscapes so immense and so unexplored is humbling. We often speak of space as the final frontier, but in many ways the ocean trenches are just as mysterious. They remind us that Earth is still larger and stranger than we give it credit for. That mystery is not something lost to the past, but something present beneath our feet. or rather, beneath our seas. It is tempting to imagine what it would feel like to stand on the floor of a trench, though of course no human could survive there unprotected. Picture towering walls rising on either side, sediment stretching into the distance, the silence broken only by the faint crack of rock shifting, or the distant calls of whales passing far above. In the glow of a submersible's light, strange creatures drift out of the dark, amphipods scuttling across the bottom, snailfish hovering gently, translucent forms pulsing through the water. And then, outside the beam, nothing. A blackness so complete it swallows even the imagination. Yet this is not emptiness, it is habitat. It is a landscape as real and as alive as any forest, desert or mountain. Its scale may be hard to hold in mind, but its reality is undeniable. Trenches shape the planet, shape life, and shape our understanding of what Earth truly is. They are not just valleys beneath the sea, they are the deepest valleys that exist, deeper than mountains are tall, reminders that the world we live on is still full of hidden extremes. As the descent continues, we leave behind the general vastness of the midnight zone and enter these more specific landscapes, carved by geology, filled with life and still barely known. Each step downward brings us closer to the heart of the Hadal zone, closer to the places where pressure, darkness and isolation meet to create forms of life unlike anything else. The trenches stretch ahead, silent and waiting, valleys deeper than mountains are tall, and within them, stories that we're only just beginning to uncover. When the first explorers and scientists began to imagine what might lie in the deepest parts of the sea, many assumed the answer was simple: nothing. The idea of life existing where pressure is crushing, where light never penetrates, and where food is scarce seemed impossible. In the 19th century, when oceanography was still a young science, there were debates about whether any form of life could survive below a few hundred meters. Even Charles Darwin, so keen an observer of adaptation on land, hesitated to believe much could exist in the abyss. The reasoning seemed sound at the time. No light meant no plants meant no food, and the sheer physical force of water pressing from above would surely make survival impossible. And yet each time humans ventured deeper, they were proven wrong. The first glimpses of life in the Hadal zone came not from humans in submersibles, but from nets and dredges dragged up from the depths. In the late 1800s, the HMS Challenger expedition trawled samples from deep waters and found, to the surprise of many living creatures, brittle stars, sea cucumbers and other invertebrates came up in the nets, battered by the ascent but alive enough to prove a point. The deep sea was not lifeless, it was simply hidden. The discovery was the beginning of a long process of overturning assumptions. With each new tool, each deeper dive, the story of life in the trenches grew richer and stranger. When Jacques Picard and Don Walsh descended in the Trieste to the bottom of the Mariana Trench in 1960, the world watched with anticipation. What would they see in a place no human had ever been? Through a tiny porthole, as their craft settled on the silty bottom nearly 11 kilometers down, they reported seeing a flatfish-like creature swimming slowly by. If true, it was astonishing. Later studies suggested what they saw might have been something else, perhaps a holothurian or a large amphipod, but the message was the same. Even at the very bottom of the ocean, something was alive. As technology improved, remotely operated vehicles and landers provided clearer evidence. Cameras lowered into trenches recorded amphipods, shrimp-like crustaceans, scuttling across the sea floor. Some were surprisingly large, nearly the size of a human hand. Their presence was more than just curiosity. Amphipods are scavengers, feeding on organic material that drifts down from above. To see them thriving in such numbers meant that even here, at the greatest depths, food webs existed. Life was not just surviving, it was doing so in abundance. One of the most remarkable discoveries of recent decades has been the Hadal snailfish. These ghostly white or pink fish have been filmed and collected at depths greater than 8,000 metres. They look delicate, with thin skin and translucent bodies, but they are perfectly adapted to their environment. Their bones are reduced, their tissues filled with buoyant gel, and their proteins protected by compounds that prevent pressure damage. They are not only present in the Hadal zone, they dominate it. In some trenches, snailfish appear to be the top predator, preying on amphipods and other small creatures. Their discovery was a turning point. Until then, many doubted that vertebrates could survive at such depths. The snailfish proved otherwise, showing that even complex animals can adapt to the crushing world of the trenches. But fish and crustaceans are only part of the story. Microbes thrive in Hadal sediments, breaking down organic material and fueling the base of the food chain. Some of these microbes are extremophils, organisms that can withstand pressure that would destroy most life. Their enzymes function only under high pressure, and their chemistry is tuned to an environment we would find utterly hostile. In laboratories, scientists struggle to keep them alive at surface conditions, a reminder that what is normal for us is deadly for them, and what is normal for them would be instantly fatal for us. Life, it seems, is always relative to the conditions in which it evolved. The presence of these microbes has far-reaching implications. They play a role in cycling nutrients, in locking away carbon, in shaping the chemistry of the deepest oceans. Their activity shows that even in the most extreme environments on Earth, life is not an afterthought. It is an integral part of the system. Every amphipod that scuttles across the floor, every snailfish that hunts in the dark depends ultimately on the invisible work of microbes recycling matter at the base of the trench. What strikes explorers most when they first see footage from the Hadal zone is not the absence of life, but the normalcy of it. Animals swim, crawl, feed, and behave as if nothing unusual is happening. To them, nothing is unusual. This is their world, the only one they know. The crushing pressure, the darkness, the scarcity, all of these conditions shape them, but do not diminish them. To us, survival here looks like defiance. To them, it is simply life as usual. There is a lesson in those first glimpses. Again and again, humans have assumed that life could not exist beyond certain boundaries. Too hot, too cold, too salty, too acidic, too deep. And again, life has appeared where we least expected it. The Hadal zone is one of the clearest examples. What once seemed impossible is now known to be thriving. Amphipods, snailfish, worms, microbes, all flourishing in a realm once thought lifeless. The first glimpses of them are more than just discoveries. They are reminders that our imagination of life's limits is often narrower than reality. And still, we have barely scratched the surface. For every species filmed or collected, countless others remain unseen. Trenches are vast and exploration is expensive and difficult. A few hours of footage represents only the tiniest fraction of what exists. The glimpses we have are tantalizing, but they are not the whole story. There are likely creatures in the Hadal zone that no one has ever laid eyes on, adapted in ways we cannot predict. Each descent, each camera drop carries the possibility of surprise. It is worth reflecting on how extraordinary this is. We live in an age where satellites can map distant planets, where probes fly beyond our solar system, and yet here on Earth, entire ecosystems remain hidden. The first glimpses of Hadal life are not the end of exploration but the beginning. They remind us that our planet is still full of mysteries waiting to be revealed. When we call this life against all odds, it is not just a phrase. The odds, as we understand them, really do seem impossible. And yet life bends those odds, reshaping itself to fit environments we cannot. These first glimpses are proof of resilience, of adaptability, of survival in places we once thought empty. They show that Earth is not a planet of narrow comfort zones, but of boundless possibility. As we continue to descend, the picture of the Hadal zone will only grow more complex. Each new discovery adds another thread to the tapestry, another detail to the story. What began as isolated glimpses will become a clearer vision, showing us not only the strangeness of these creatures, but the connections they share with life everywhere. The Hadal trenches are not lifeless voids. They are habitats filled with residents who have always been there, waiting for us to notice. And now that we have, the question is no longer whether life exists in the depths, but how much more there is to find. The further we go into the trenches, the clearer it becomes that survival here is not about resisting the environment, but about becoming inseparable from it. The pressure, the cold, the absence of light. These are not obstacles for the creatures of the Hadal zone. They are the very conditions that shape their bodies, their chemistry, and even the way their lives unfold. To understand how life endures in a world where pressure would crush steel and darkness is endless, we have to look at the extraordinary adaptations that make survival possible. One of the first things you notice about deep-sea creatures is their appearance. Many of them look fragile, soft, even ghostly. The Hadal snailfish, for example, is translucent, with skin so delicate it almost seems unfinished. Its bones are reduced to thin supports, and in some cases nearly absent altogether. On the surface, this would be a disadvantage. Without solid structures, most animals would collapse under their own weight. But in the trenches, heavy bones would be a liability. The pressure would crack and crush them. A softer, more gelatinous body, on the other hand, simply compresses and flexes with the surrounding water. What looks fragile to us is, in fact, resilience perfectly tuned to conditions we cannot endure. Another striking feature is the absence of gas-filled structures. Many shallow water fish use swim bladders, organs filled with air, to control buoyancy. But in the Hadal zone, air is a dangerous weakness. Under pressure, any cavity filled with gas would collapse instantly. Hadal creatures avoid this problem altogether by eliminating such organs. Instead, they rely on buoyant gels and specialized tissues to achieve neutral buoyancy. Their bodies are built not to resist collapse, but to flow seamlessly with the crushing environment around them. At the molecular level, adaptations become even more remarkable. Proteins, the tiny machines that make cells work, are sensitive to pressure. At high pressures, they can lose their shape, a process called denaturation, and once that happens, they no longer function. Most life on Earth depends on proteins folding correctly, so this is no small problem. Hadal organisms solve it with chemistry. They produce compounds known as piezolites, molecules that stabilize proteins under pressure. One of the most important is trimethylamine N oxide, or TMAO. At shallow depths, fish have only small amounts of it. But in the Hadal snailfish, levels of TMAO are far higher, providing stability for their proteins even under extreme conditions. The very smell of the fish, that sharp, fishy odour we recognise from markets, comes from this chemical. In a sense, the stronger the smell, the stronger the adaptation. Cell membranes face similar challenges. Normally, membranes are flexible layers of fat molecules that enclose the contents of cells. Under pressure, they can stiffen, losing the ability to let nutrients and signals pass. Hadal organisms counter this by packing their membranes with unsaturated fats, which remain fluid even when squeezed by immense pressure. The result is a living boundary that keeps functioning where ours would freeze into rigidity. Even DNA and enzymes must adapt. In Hadal microbes, researchers have found unique versions of enzymes that work only under pressure. When brought to the surface, they fail completely, unable to function in what, for us, is normal air pressure. To them, our world is as hostile as theirs seems to us. Life is relative. What feels impossible to one species is simply background noise to another. Survival in the trenches also requires strategies for energy. Food is scarce, and what little arrives comes mostly from above, in the form of marine snow or larger carcasses sinking through the water. To make the most of this limited supply, many Hadal creatures have slow metabolisms. They move carefully, conserving energy. Their bodies are often small relative to their environment, minimizing demands. Predators like snailfish can go long stretches without meals, waiting patiently for amphipods or other prey to appear. Scavengers pick apart every scrap of organic matter, leaving nothing wasted. In a world where meals are unpredictable, efficiency is everything. Size itself is an adaptation with curious patterns. Amphipods in the trenches are often far larger than their shallow water relatives, sometimes growing to the size of a hand. This phenomenon, known as deep-sea gigantism, is not fully understood, but it may be related to slower metabolisms, fewer predators, and colder temperatures. Bigger bodies may help them store energy, resist starvation, and navigate the high-pressure environment more effectively. In contrast, other creatures shrink in the deep, becoming tiny specialists that exploit narrow ecological niches. Whether large or small, size is always shaped by survival needs, not by any single universal rule. Light, or rather its absence, also drives adaptation. Many Hadal creatures are blind, having lost their eyes through evolutionary time. Others retain eyes but in unusual forms, large, bulging, sensitive to the faintest glimmers of bioluminescence. Some produce light themselves, glowing with chemical lanterns that serve as lures, camouflage, or communication. Each strategy is a response to darkness, a solution to living in a world where sunlight will never reach. Reproduction, too, must adapt. Finding a mate in the vast dark expanse of the Hadal zone is no easy task. Some species rely on chemical signals, releasing pheromones into the water that can be detected across great distances. Others use light displays, patterns of bioluminescence that act as beacons in the black. Some, like certain deep-sea anglerfish, even resort to extreme strategies, with tiny males attaching themselves permanently to much larger females, fusing bodies to ensure reproduction in a world where encounters are rare. It is easy to see these adaptations as strange, even alien, but they are logical responses to the environment. Each one is a solution to a problem we cannot feel, but that defines every moment of life in the trenches. Pressure threatens structure, so bodies are soft. Scarcity limits energy, so metabolisms are slow. Darkness eliminates vision, so new senses or lights evolve. The Hadal zone is not a place where life cheats death. It is a place where life is written in different terms. What makes these adaptations even more fascinating is their potential to teach us about life beyond Earth. Moons like Europa and Enceladus have oceans sealed beneath ice, environments where sunlight cannot penetrate. If life exists there, it would need adaptations much like those of the Hadal zone: pressure resistance, energy efficiency, and alternatives to photosynthesis. Studying Earth's trenches gives us a model, a glimpse of what alien biology might look like. The strange bones, bodies, and chemistry of Hadal creatures are not only about survival here, but about possibility everywhere. And yet, for all we know, there is far more we don't. The trenches are vast and exploration is limited. Every new dive has the potential to reveal adaptations we have never seen before. Perhaps creatures with completely novel ways of managing pressure, with chemistries unknown to science, or with life cycles that challenge our understanding of biology. Each adaptation discovered so far is a reminder that life does not obey our expectations. It finds ways where we imagine none. When we call these adaptations strange, it is only because they differ from our own. To the amphipod, growing large is natural. To the snailfish, a body without a swim bladder is normal. To the microbe, enzymes that collapse at surface pressure are the only kind that make sense. The real strangeness is not in them, but in our assumptions. Life is not fragile. It is endlessly inventive, endlessly adaptive, endlessly able to fit itself into the cracks and extremes of existence. The trenches are the clearest proof of this. In a world defined by crushing weight, freezing cold, eternal dark, and scarce food, life still thrives. It does not resist the environment but flows with it, reshaping bones, bodies, and chemistry, until survival is not just possible but inevitable. And as we continue to explore, we will see that the story of adaptation in the Hadal zone is not finished. It is still being written, one strange solution at a time. In the trenches, where sunlight has never reached and never will, light does not disappear completely. It returns in another form, born not from the sky, but from the bodies of the creatures that live there. This is bioluminescence, the ability of organisms to produce their own glow. To call it extraordinary almost feels too small. On the surface, light is something we take for granted. It pours down from the sun, reflects off the moon, scatters through clouds and bends through windows. In the Hadal zone there is no such luxury. The only lights are the ones life makes for itself, tiny lanterns flickering in a sea of black. The chemistry is simple in principle, but astonishing in practice. Specialized molecules react with oxygen mediated by enzymes and release energy as visible light. Different species have refined this chemistry in different ways, producing glows that range from faint green to deep blue, sometimes even reaching into red, which is rare underwater because most creatures cannot see it. What matters is not the process itself, but how it is used. In the deep sea, light is not just a way to see. It is a tool for survival, a form of communication, a weapon, a disguise, and sometimes a trap. Consider the anglerfish, perhaps the most famous example. A small lure dangles from its head, tipped with a glowing bulb. In the endless black of the deep, that glow is irresistible to smaller creatures searching for food. They drift closer, curious, and when they are near enough, the anglerfish's jaws snap shut with speed that belies its slow drifting posture. In an environment where meals are rare, this simple trick is enough to keep the predator alive. What looks to us like a strange deformity is, for the anglerfish, a perfect adaptation, an invention of light to replace the sunlight that will never shine there. Other creatures use bioluminescence defensively. Some squid release bursts of glowing fluid, clouds of shimmering distraction that confuse predators long enough for them to escape. Some fish flash suddenly, startling attackers. Others glow steadily to blend into faint light from above, a trick called counter-illumination. Seen from below, they vanish against the dim traces of downwelling light, erasing their silhouettes. Even in the Hadal zone, where the surface glow no longer penetrates, some animals retain these adaptations, perhaps because they migrate upward, or because the ability to manipulate light remains useful even in total darkness. There are creatures that use light for communication. Patterns of glowing spots line their bodies, each with specific arrangements that can identify species, gender, or readiness to mate. In a world without voices, without colours, without sunlight, this becomes language. A flicker in the dark, a sequence of pulses, a soft glow moving rhythmically. These are signals that carry meaning across the black water. Imagine if every sentence you spoke appeared not as sound but as light. Each word a sparkle, each phrase a ripple of glow. That is the silent conversation of the deep. Some bioluminescence is stranger still. Certain jellyfish, when disturbed, release glowing particles that drift away, drawing predators toward the light and away from the jellyfish itself. Some worms glow only when they break apart, their dismembered bodies continuing to shine, distracting attackers while the main body slips away. Even bacteria participate, colonizing the organs of fish and providing light in exchange for shelter. In this way, bioluminescence is not only an adaptation of individuals, but sometimes a partnership between species, a cooperative invention of glow in the dark. In the Hadal trenches, where pressure is immense and food is scarce, light can mean the difference between survival and starvation. Amphipods may be drawn toward faint glows, snailfish may use the flashes of their prey to locate them, and scavengers may detect a glowing disturbance that signals opportunity. Each flicker is both risk and chance. To glow is to reveal oneself, but it is also to lure, to warn, or to communicate. In a world where sight is almost useless, light becomes one of the few reliable ways to send a message. What is remarkable is how widespread bioluminescence is. It is not rare, not confined to a few strange species. More than 3/4 of organisms in the mid-water deep sea produce light in some form. It is the rule rather than the exception. This raises an intriguing thought. On land, we think of light as belonging to the sun, as something external to life. Fireflies are charming because they are exceptions. In the ocean depths, it is the opposite. Here, light belongs to life itself. It is not borrowed from the sky, but made from within. Scientists studying bioluminescence often describe it as one of the most efficient light sources known. Unlike a flame or a bulb, there is almost no wasted heat. Nearly all the energy is converted into light, a necessity in an environment where energy is scarce. Evolution has refined this efficiency over millions of years, producing systems that human engineers still struggle to match. In this sense, the deep sea is not only a place of survival, but a library of natural technologies waiting for us to understand them. For us, the idea of swimming in total darkness punctuated by glowing creatures might sound otherworldly, almost like drifting through space among stars. And in a way, that comparison is not far off. Both are vast, both are silent, both are places where our senses struggle to comprehend scale. But unlike space, the deep sea is alive. Each point of light is not a distant sun, but a living being, signalling, hunting, escaping, or simply existing. To watch bioluminescence in action is to realize that darkness does not mean emptiness. It means contrast, a stage for life's lanterns to shine. Even in the Hadal zone, where bioluminescence may seem less frequent than in the higher midnight zone, it still plays a role. Amphipods glow faintly. Some snailfish have been observed reflecting or responding to light. The boundaries between zones are not strict. Creatures move up and down, carrying their abilities with them, spreading glow into the deepest places, and where light appears, life notices. There is a quiet beauty in this, but also a profound lesson. We often imagine survival as a struggle against the environment, a fight to resist darkness, pressure, and cold. But bioluminescence shows us another path. It is not resistance, it is invention. Where sunlight fails, life simply creates its own. It is not the same light, not as bright, not as warm, but it is enough. It is survival written in photons instead of leaves or fire. For the animals themselves, these lights are not magical. They are practical. A lure to catch food, a flash to startle danger, a glow to find a mate. But for us, looking in from the outside, they remind us of the creativity of life. No matter how impossible the conditions seem, no matter how absolute the darkness, life finds a way to leave its mark, to shine however faintly against the void. And so the trenches, though hidden from the sun, are not truly dark. They are dotted with sparks, with signals, with silent lanterns drifting slowly through the water. Each one is a story of adaptation, of chemistry, of survival. Each one is proof that even where light cannot follow, life brings its own. When most people think of life in the ocean, they picture fish, whales, squid, or perhaps glowing jellyfish drifting through the dark. What usually goes unnoticed are the organisms too small to see, yet far more abundant than all the rest. In the Hadal trenches, microbes dominate in ways that make them not only residents of the depths, but the very foundation of its ecosystems. While snailfish and amphipods capture our attention with their strangeness, the truth is that it is the invisible bacteria and archaea living in sediment and stone that make the survival of everything else possible. The seafloor of a trench is not flat or lifeless. It is a patchwork of fine sediments, rocky slopes, and fractured surfaces where currents deposit material carried down from above. Into this layer of mud and stone, life has seeped quietly over millions of years. Microbes colonize every grain, every pore of sediment, and every crack in the rock. To them, the crushing pressure, the cold near freezing, and the absence of light are not barriers but normal conditions. For humans, this is an environment impossible to endure. For these microorganisms, it is simply home. What makes microbial life in the trenches so fascinating is not just that it exists, but that it thrives in ways different from anything on the surface. At these depths, energy is scarce, photosynthesis is impossible, and the steady rain of marine snow provides only a thin trickle of carbon, yet microbes find ways to extract energy from what little arrives. They break down organic matter buried in sediments, recycling it into nutrients that other organisms can use. They oxidize chemicals like methane, ammonia, and hydrogen sulfide, using them as fuel in the absence of sunlight. Some even extract energy directly from minerals in the rocks around them, pulling electrons from iron or manganese in a process that seems more like geology than biology. This makes them extremophiles in the truest sense. Their enzymes, the tiny molecular machines that drive life, are stable under pressures that would collapse the chemistry of ordinary cells. Their membranes stay fluid despite the squeeze of thousands of atmospheres. Some have even been shown to grow better under pressure than without it, making our world at the surface hostile to them, while the Hadal zone is the only place where they truly flourish. For us, these conditions are extreme. For them, the surface is extreme. Perspective shifts depending on where you stand, or in this case, where you sink. Scientists studying microbes from trench sediments often bring samples back to the surface in pressurized containers, because without those conditions, the organisms may die before they can be examined. When they are studied properly, the findings are striking. Many Hadal microbes grow faster under pressure, not slower. Their enzymes work only when compressed. Their DNA stabilizing proteins perform better when squeezed. These creatures are not tolerating pressure, they require it. To think of life depending on what to us is destruction feels paradoxical, but it is one of the most important lessons of the deep. Their role in the ecosystem cannot be overstated. Without microbes, the larger creatures of the trenches could not survive. Amphipods and snailfish depend indirectly on the recycling work of bacteria and archaea. Organic matter that drifts down from above is often too complex for larger animals to use directly. Microbes break it down into forms that can be absorbed, continuing the cycle of life in the dark. Even whale falls, those massive carcasses that sink to the seafloor, become ecosystems dominated first by scavengers, but then by microbial colonies that digest bone and fat for years, sustaining entire communities long after the initial feast is gone. The influence of microbes goes beyond immediate survival. In the sediments of the trenches, they also regulate carbon storage on a planetary scale. By breaking down organic matter and burying the rest, they lock away carbon for millions of years, shaping the Earth's climate in ways we barely understand. Without their work, the atmosphere above would hold far more carbon dioxide. The invisible life in the mud of the trenches has consequences for the air we breathe, the temperatures we live in, and the stability of the climate itself. The smallest organisms in the deepest places hold the reins of global systems. It is not only carbon that they influence. Some trench microbes specialize in nitrogen, converting it from one chemical form to another, maintaining balance in the oceans. Others handle sulfur, turning toxic hydrogen sulfide into usable forms of energy. The diversity of metabolisms is astonishing. Where surface life is bound tightly to the chain of photosynthesis, deep-sea microbes invent countless other strategies, proving that life does not need a sun at all. It only needs a way to capture energy, no matter how unlikely. One of the most exciting discoveries of recent years is that microbes in the Hadal zone are not just surviving passively, but are active participants in shaping their environment. Studies show they can adapt quickly to new conditions, switching energy sources, altering their metabolic pathways, and forming biofilms that stabilize sediments. They even create symbiotic relationships with larger organisms living inside amphipods or snailfish guts, helping their hosts digest scarce food. These partnerships are invisible to the naked eye, yet they define the survival of species we can see. It is easy to forget them because we cannot watch them the way we can a glowing fish or a drifting jelly. But if we could shrink down and peer into the mud, we would see a world every bit as active as the larger ocean above. Filaments of bacteria creeping through pores in the sediment, colonies clustering around tiny fragments of organic matter, chains of cells metabolizing chemicals in silence. Each grain of sand or silt would be a miniature ecosystem, bustling with unseen activity, the smallest units of survival feeding into the largest. For astrobiology, the study of life beyond Earth, these microbes are perhaps the most important discovery of all. If life can survive in the Hadal trenches, relying on chemistry instead of sunlight, then perhaps it can exist in similar environments elsewhere. Beneath the icy crust of Europa, or Enceladus, where oceans are sealed away from the sun, microbial life could thrive in sediments or along hydrothermal vents, much as it does here. The trenches show us that life does not require a blue sky or a warm sun. It requires only a way to make energy from the environment, however strange that environment may be. But the study of these microbes is still in its infancy. Every expedition brings back new strains, new enzymes, new metabolisms that challenge what we thought possible. Some can resist not only pressure, but also toxic chemicals. Some appear to remain dormant for astonishing lengths of time, waiting for nutrients to arrive. Others form spores that might survive for millennia. Each discovery expands the boundary of life's resilience, pushing back against the idea that any place on Earth is too extreme. What makes them most remarkable is how unremarkable they are to themselves. They do not know they are unique. They are not aware of their strangeness. They simply live, dividing, consuming, metabolizing, just as microbes do everywhere. The difference is that their home is 11 kilometers beneath the sea, in mud compacted by unimaginable weight. To them, this is not an adaptation. It is normal. To us, it is extraordinary. As our descent continues, it is worth keeping them in mind. The snailfish, the amphipods, the glowing squid. They capture attention because we can see them, because they move and remind us of ourselves. But without the microbes, none of those creatures could exist. Life in the trenches begins at the microscopic scale, in the quiet chemistry of sediment and stone. The first glimpses of them remind us that survival is not about grandeur but about persistence. Even in the deepest valleys of the ocean, the smallest cells hold everything together. When we think of the Hadal trenches, the first images that come to mind are often of darkness, mud, and invisible microbes. But among the unseen chemistry and tiny cells, there are also giants, at least giants by the standards of the deep. They are not enormous compared to whales or sharks, but in the context of a place where we once believed nothing could survive, their size feels almost exaggerated, a declaration that life does not only scrape by in the trenches, it flourishes. Amphipods the length of a hand, ghostly snailfish hovering like spirits, creatures with shapes so strange they seem designed not for Earth, but for another world entirely. These are the marvels of the Hadal zone, proof that survival is not hidden only in the microscopic, but made visible in living forms that swim, crawl, and thrive. Among the most iconic are the amphipods. To the untrained eye, they look like oversized shrimp, segmented bodies with jointed legs scuttling across the seafloor or swimming clumsily in the water. But what makes them remarkable is their scale. In shallow water, amphipods are usually tiny, just a few millimeters long. In the trenches, they grow to lengths of 10, even 15 centimeters, large enough to fill a human palm. In a world where food is scarce and pressure immense, why would such small creatures evolve into giants? Scientists call this phenomenon deep-sea gigantism, and while the reasons are still debated, there are theories. Colder temperatures slow metabolism, allowing animals to grow larger over longer lifespans. High pressure may favour bigger body structures that can handle the squeeze, and with fewer predators around, there is less evolutionary pressure to stay small and hidden. Whatever the cause, the result is striking. To see a hand-sized amphipod scuttling across the bottom of a trench is to realise how strange life can become when pushed to its limits. Amphipods are more than curiosities. They are essential to the ecosystem. Scavengers by nature, they swarm to any organic material that falls to the seafloor, breaking it down into pieces small enough for other creatures and microbes to finish consuming. They are the cleaners of the trenches, recycling whatever comes their way. In experiments, researchers have baited cameras with fish carcasses lowered into the depths. Within hours, amphipods gather in swarms, stripping the flesh with remarkable efficiency. Without them, the limited resources of the trenches would vanish too quickly. With them, nothing is wasted. Even more astonishing are the snailfish, pale, gelatinous predators that glide effortlessly through the Hadal waters. For years, scientists doubted that vertebrates could survive under such pressure. Bones, it was thought, would not hold up. Complex organs would fail. Yet snailfish have not only survived but seem to thrive, with populations recorded in several trenches around the world. Their bodies are translucent, sometimes nearly see-through, with soft tissues instead of rigid structures. Their bones are reduced to the bare minimum, enough to provide shape but not enough to become fragile under pressure. Instead of swim bladders, which collapse instantly at depth, they rely on gelatinous tissue to maintain buoyancy. Every part of their anatomy is adapted for the deep. What makes them most fascinating is not just their survival, but their success. In some trenches, snailfish are the top predators, feeding on amphipods and smaller invertebrates. Cameras lowered into the Hadal zone often record them gliding gracefully in and out of view, their movements slow and deliberate, their mouths opening to swallow prey whole. Despite their delicate appearance, they dominate in an environment that should be too extreme for creatures of their complexity. Their very existence rewrote scientific expectations about the limits of vertebrate life. Beyond amphipods and snailfish, there are countless other marvels. Holothurians, or sea cucumbers, drift along the seafloor, their bodies strange and rubbery, feeding by ingesting sediments and extracting nutrients. Giant isopods, distant relatives of woodlice, scavenge in slow motion. Polychaete worms, bristling with tiny appendages, crawl through the mud. Some are scavengers, others predators, each filling a niche in a food web that, while fragile, is surprisingly complete. Even at these depths, where conditions seem impossible, ecosystems are as varied as any on the surface. Occasionally cameras capture rarer sights, deep-sea jellyfish pulsing in the darkness, cephalopods stretching their arms in slow arcs, creatures so delicate they collapse when brought to the surface. Each glimpse is a reminder that we are only seeing fragments of what is really there. The trenches stretch for thousands of kilometres, their walls and floors unexplored except for brief visits. The giants we know, amphipods and snailfish, are likely just the beginning. What makes these creatures marvellous is not only their biology but their context. Against the backdrop of crushing weight and total darkness, their presence feels almost miraculous. But to them, nothing is miraculous. Their adaptations are simply survival, written into their genes over countless generations. They do not fight the environment, they embody it. Their bones, their chemistry, their bodies, all are shaped to fit perfectly into the trenches. Where we would be crushed, they glide. Where we would starve, they feed. Where we imagine emptiness, they build entire lives. The fascination with giants in the deep is not only scientific but human. There is something compelling about large creatures surviving where we expect only microbes. It makes the invisible world of the Hadal zone suddenly tangible, something we can picture, something we can imagine moving before us in the glow of a submersible's lamp. Seeing amphipods swarm or snailfish hover makes the trenches feel real, not just abstract depths on a map. They remind us that life is not confined to the familiar shallows, but extends into every corner, even those hidden under the greatest weight. And yet, even with these discoveries, there are questions. Why do some trenches harbour more snailfish than others? Why do amphipods grow so large in certain regions but remain smaller in others? How do populations survive in isolation, separated by vast distances of ocean floor? Each answer brings new mysteries, each glimpse suggesting that what we know is still a fraction of what exists. The giants of the deep are ambassadors of a world we barely understand, hints of the diversity waiting in the silence below. As the descent continues, the presence of these creatures becomes a reassurance. The trenches are not barren, they're alive, filled with movement and survival, in forms both familiar and strange. Amphipods scuttling, snailfish gliding, holothurians feeding, each one a marvel in its own right, each one a reminder that even in the harshest places life does not give up. It adapts, grows, and sometimes even grows large. When we watch footage from the deepest parts of the ocean, one of the most surprising impressions is how fragile many of the creatures appear. Their bodies are soft, translucent, sometimes barely more than gel held together by thin membranes. In the Hadal zone, where pressure is unimaginably high and light absent, this fragility is not weakness but strength. Yet, it is a kind of strength that only exists under those conditions. The same adaptations that let them survive in the trenches make them too delicate for the surface. Remove them from their world, and they collapse, dissolve, or perish almost instantly. Their beauty is real, but it belongs entirely to the deep. The first time researchers brought snailfish up from the Hadal depths, they found that the animals did not survive the journey. Their bodies, so perfectly tuned to pressure, could not function without it. The molecules stabilizing their proteins, the soft tissue supporting their bodies, the chemistry holding their cells together, all of it depended on being squeezed from every side. At the surface, that squeeze is gone, and what remains cannot hold. To call them fragile is accurate from our point of view, but misleading from theirs. In their world, they are perfectly resilient. It is only when we take them out of context that they seem delicate. The same is true of amphipods. Though larger than their shallow water relatives, Hadal amphipods have thin shells, flexible exoskeletons, and internal chemistry built for pressure. In experiments, when they are raised to the surface, their bodies often rupture. The compounds that stabilize their cells at depth become toxic without the crush of pressure. Trimethylamine N oxide, so useful in stabilizing proteins under pressure, builds to levels that would overwhelm other organisms. At 11,000 meters, this is protection. At sea level, it is poison. What is salvation in one environment is destruction in another. Other creatures show this even more dramatically. Delicate jellyfish and gelatinous zooplankton collected in nets often collapse into shapeless masses before they can be studied. Their structures, so light and graceful in the water, cannot hold without the buoyancy of pressure supporting them. They are built to float, not to resist gravity. On the seafloor of a trench, they may pulse gently, drifting with the currents. But in our world of air and gravity, they become formless. What looks fragile on deck is thriving in the deep, where every detail of the body is in balance with its surroundings. It is a strange reversal. On land, we value hardness, durability, resistance. But in the trenches, those qualities are liabilities. Bones crack, shells shatter, cavities collapse. Softness, flexibility, and delicacy are what endure. To live in the Hadal zone is to live as water does, yielding to pressure rather than resisting it. Strength here is found in fragility. Survival is achieved by being delicate enough to bend, transparent enough to vanish, light enough to float. It is a lesson written into every creature of the deep. For scientists, this fragility creates enormous challenges. Bringing animals to the surface almost always kills them. What we study in laboratories is often a distorted version, damaged by the very act of collection. To see them truly, we need technology that can observe them in place. Cameras mounted on landers, submersibles with floodlights, instruments designed to work under pressure. These are our windows. Without them, the creatures remain hidden. because they cannot exist outside their home. Their beauty is fragile, but only from our perspective. In their own environment, they are whole. Some researchers have begun to design pressure-retaining chambers, devices that bring animals to the surface without releasing the crushing force around them. With these, a snailfish or amphipod can be observed alive, behaving as it would in the trenches. These rare glimpses reveal how natural their lives are under conditions that to us seem impossible. They swim, feed, and move with no sign of strain. To them, it is the absence of pressure that is deadly. To us, it is the presence of pressure. Life defines its own normal, own. Fragile beauty is just another way of saying that survival depends entirely on place. The delicacy of these animals raises interesting questions about resilience in a broader sense. We often assume that to be resilient is to be hard, to resist change, to withstand. But in the Hadal trenches, resilience is the opposite. It is about yielding, about becoming so finely tuned to the environment that survival is effortless. What seems fragile outside is unshakable within. Amphipods bursting at the surface are not weak. They are evidence that life can adapt so completely to one environment that it becomes inseparable from it. Their fragility is proof of perfection, not imperfection. Even their appearance reflects this. Transparent bodies are not a flaw but camouflage, making them invisible in the dark. Thin skins reduce energy costs and allow more efficient exchange of chemicals. Gelatinous tissues provide buoyancy without air cavities. Each of these traits looks delicate to us, but each is essential to thriving under pressure. Beauty, in this context, is not about boldness or durability. It is about subtlety, balance, and precision. What these creatures remind us is that survival has no single formula. On the surface, we prize sturdiness. In the trenches, delicacy reigns. On land, strength is measured in resistance. In the Hadal zone, it is measured in adaptation. Fragile beauty is not weakness, but the ultimate form of fitting into a place so extreme that only the most finely tuned organisms can endure it. The more we learn about these animals, the more we realize how narrow our definition of resilience has been. To be too delicate for the surface is not failure. It is evidence that life can specialize to such a degree that it becomes unimaginable anywhere else. Amphipods, snailfish, jellies, worms, all carry this lesson. They show us that fragility can be strength, that beauty can be survival, and that the deepest places on Earth are not barren voids but habitats filled with creatures whose very existence redefines what it means to endure. If there is one constant challenge of life in the trenches, it is food. In shallow waters, sunlight feeds microscopic plants, which feed countless fish, which in turn feed everything else. But in the Hadal zone, there is no sunlight, no photosynthesis, no green base to start the food web. Instead, every scrap of nourishment comes from above. Life in the deepest places is tied, often literally, to the surface world it never sees. The most common source of this connection is what scientists call marine snow. It sounds poetic, but it is quite literal. Tiny particles of organic matter drift down from the upper ocean, falling slowly like flakes through the water column. They are not flakes of ice, but bits of dead plankton, fragments of fecal pellets, specks of mucus, and the remains of countless organisms that lived and died in the sunlight zone. Each particle is minuscule, but together they form a constant rain that never stops. Day and night, year after year, marine snow drifts into the depths, carrying energy from the surface to the Hadal floor. Imagine sitting in total darkness and waiting for food to arrive not as meals, but as dust. That is the reality for many Hadal creatures. Amphipods pick through sediments, gathering particles that settle on the bottom. Sea cucumbers ingest whole mouthfuls of mud, extracting what little nutrition is buried inside. Even microbes depend on this steady supply, breaking down particles into forms other organisms can use. The Hadal ecosystem is built on patience, on extracting value from the smallest of gifts. Marine snow is not abundant, but it is constant, and over time it sustains life across the deepest valleys. Sometimes, larger meals arrive. A fish dies near the surface and drifts down, a body carried by currents until it settles in the deep. To the scavengers of the trenches, this is a feast, a rare windfall in a world of scarcity. Amphipods swarm quickly, stripping flesh in hours. Isopods and worms move in to consume what remains. Microbes colonize the tissues, breaking them down long after larger scavengers are done. Nothing is wasted. In the trenches, every death above becomes survival below. But the most dramatic events are whale falls. When a whale dies at the surface and sinks, its massive body becomes an entire ecosystem on the seafloor. At first, scavengers descend, tearing away the flesh. Sharks, if they are near, may take part before the carcass sinks too deep. But in the trenches, it is usually amphipods, isopods and snailfish that gather. Within weeks, the soft tissues are gone, but the story does not end there. The bones themselves, rich in lipids, provide food for specialized bacteria and worms that can survive for years feeding on the remains. Around these microbes, whole communities grow, species that exist almost exclusively on whale falls, adapted to exploit this rare but massive pulse of energy. A single whale can sustain life on the seafloor for decades. In the Hadal trenches, where large meals are rare, a whale fall is like a city springing up overnight, flourishing as long as resources last. These events remind us how connected the surface and the depth truly are. A whale feeding in the bright shallows of the open ocean eventually carries that energy into the dark trenches when it dies. The cycle of life above becomes the foundation of survival below. Even creatures that never see light are tied to those that bask in it. The connection is not occasional, it is constant. Every fragment of marine snow, every sinking fish, every fallen whale is a bridge between worlds. For scientists, studying this flow of food is essential to understanding the trenches. Without it, the Hadal zone would be sterile. With it, life flourishes. The efficiency is remarkable. In experiments where bait is lowered on cameras, amphipods gather within hours, even at depths of 10,000 meters. They must sense chemical signals drifting in the water, allowing them to locate food from surprising distances. When they arrive, they strip carcasses quickly, reducing them to bones in astonishingly short times. This speed is survival. In the trenches, food does not last long. Whoever arrives first gets the most, and those who hesitate may get nothing at all. Even microbial life shows remarkable efficiency. Certain bacteria are able to colonize new organic matter within hours, producing enzymes that break down complex tissues into simpler compounds. Other microbes consume the byproducts, creating chains of recycling that ensure nothing is wasted. The Hadal zone may seem like a desert, but in reality, it is more like a marketplace where every scrap of energy is bought, sold, and consumed until nothing remains. The scarcity also shapes behavior. Many Hadal animals have slow metabolisms, conserving energy so they can survive long stretches between meals. Some can gorge when food arrives, storing fat or nutrients in tissues to last through lean times. Others grow slowly, reaching maturity over years, ensuring that the limited food supply is enough to sustain reproduction. Life here is not about constant abundance. It is about endurance, about making do with what falls from above. Whale falls stand out because they create abundance in a world of scarcity. For scientists who discover them, they are almost mythical, rare treasures that reveal how dynamic the trenches can be. Around whale bones, unique species of worms called ostiacs have been found, burrowing into the skeleton and feeding with the help of symbiotic bacteria. These worms lack mouths and stomachs, relying entirely on their microbial partners to digest the fats within the bone. Around them gather scavengers, predators, and other opportunists, all benefiting from the bounty. It is a reminder that even in the most extreme environments, ecosystems can bloom suddenly when energy is plentiful. What is striking is how these events tie into the global cycle of life and death. The fall of a whale into the trenches is not just an isolated event. It is part of Earth's system of recycling, a transfer of energy from the surface to the depths, from one ecosystem to another. Without these transfers, the Hadal zone would be barren. With them, it becomes vibrant, filled with creatures that depend on the occasional abundance amid the constant trickle of marine snow. To think of survival in the trenches is to think of waiting for the next particle of snow, the next carcass, the next whale. Patience is the defining trait of Hadal life. But when food arrives, it is met with speed, efficiency, and complete use. Nothing is left behind, nothing wasted. In this balance of scarcity and sudden abundance, life finds its rhythm. And so, the trenches are not isolated after all. They're tied to the surface by threads of food, by particles drifting for weeks, by bodies sinking for days, by whales carrying their life's energy into the dark after death. The connection is profound. The light of the sun feeds plankton, the plankton feed fish, the fish feed whales, and in time, the whales feed the trenches. The circle is unbroken, even at the deepest points on Earth. Life above and life below are one story, written in particles, carcasses, and falls. When we use the word extreme, we usually mean something on the edge of possibility. Extreme cold, extreme heat, extreme depth, extreme pressure. Environments where survival seems unimaginable. And yet, across the planet, life has not only crept into these places, but adapted so completely that the extremes are no longer extraordinary. The Hadal trenches are one of the clearest examples of this, home to extremophiles, organisms that make survival under pressure, darkness, and scarcity not a challenge, but a way of life. To understand why extremophiles are so remarkable, we have to look at what makes the Hadal zone extreme to begin with. Temperatures hover just above freezing. Pressure increases by 1 atmosphere every 10 meters, reaching more than 1,000 atmospheres in the deepest trenches. Sunlight never penetrates, so photosynthesis is impossible. Oxygen is limited. Food arrives only sporadically, mostly from the surface. By every measure we apply from the surface world, this is an impossible habitat. And yet, here are microbes growing only under high pressure, amphipods the size of a hand, snailfish gliding with ease, all built from adaptations that turn impossibility into normality. Extremophiles in the Hadal trenches are not only surviving, but offering us clues about life's potential in the universe. For decades, scientists assumed that Earth's habitable zone was defined by sunlight and mild conditions, but the discovery of life in deep-sea hydrothermal vents and in the trenches overturned that assumption. Extremophiles showed us that life does not need sunlight at all, it does not need warmth, it does not need abundance, it needs only a source of energy, a way to stabilize its molecules and time to adapt. Microbes in the Hadal sediments are among the best examples. Their enzymes work only under pressure. Take them to the surface and they stop functioning. Their DNA is stabilized by proteins that would be useless at sea level. They metabolize chemicals from rocks, extracting energy where we would see only inert geology. Some live in complete darkness, fueled entirely by chemical reactions. If such organisms exist on Earth, why not beneath the ice of Europa, where Jupiter's moon hides a saltwater ocean beneath kilometers of frozen crust? Why not on Enceladus, Saturn's moon, where plumes of water vent into space, hinting at chemistry below? The Hadal trenches are not just part of Earth's story. They are analogues for alien oceans, previews of what life might look like far from the sun. The very word extremophile shows how much of this is about perspective. To us, these organisms are extreme. To themselves, they are simply alive, doing what organisms have always done, adapting to their surroundings. The Hadal snailfish is not aware that its proteins are fortified against pressure. Amphipods do not know they are larger here than in shallower waters. Microbes do not realize that their entire metabolism seems impossible to us. They are not extreme, they are ordinary within their own context. We are the ones assigning the label because we see the world from the surface. What makes them useful to us, though, is precisely this difference. Studying extremophiles gives us models for resilience beyond the limits we assumed. Their enzymes inspire biotechnology, used in industrial processes that require high pressures or temperatures. Their survival strategies inform medicine, chemistry, and engineering. More profoundly, they stretch the boundaries of where we think life could exist. If microbes can thrive 11 kilometers below the ocean, they could also thrive under the ice of alien worlds, or even within the rocks of Mars sheltered from radiation. Extremophiles tell us that life is not fragile. It is opportunistic, inventive, and willing to exploit any crack the environment leaves open. Even large organisms like the snailfish play a role in this lesson. For years, biologists argued about the depth limit of vertebrate life. Surely bones and organs would fail beyond a certain pressure. Yet in the Mariana and Kermadec trenches, snailfish were filmed at more than 8,000 meters, perfectly at home. Their very existence pushed the limit further than expected. If vertebrates can live there, why not deeper still? Each discovery moves the line outward, each extremophile reminding us that our definitions are temporary. The role of these creatures extends beyond science into imagination. When we picture alien life, we often think of strange beings under exotic suns. But perhaps the first alien life we encounter will look more like Hadal microbes than like us. Tiny cells, invisible without a microscope, adapted to cold, dark, high-pressure oceans beneath ice. If that is the case, then the trenches are already showing us the closest preview we can get. Studying extremophils here is like practicing for discoveries elsewhere. Each time we identify a new adaptation, we're not only learning about Earth, but preparing to recognize life on other worlds. Even the chemistry of extremophils carries lessons. Many produce unique molecules to stabilize proteins and membranes. These molecules, like TMAO in snailfish or piezolites in microbes, are unlike anything surface organisms require. They are evolutionary inventions, new solutions written into the code of life. If life exists elsewhere, it may have invented its own molecules too, compounds unlike any we know, but serving the same purpose, making survival possible under alien conditions. The trenches show us that life is not limited to familiar chemistry. It is endlessly creative with the building blocks it has. There is also humility in this. For centuries, humans placed themselves at the center of biology, assuming that life everywhere would resemble us, or at least require what we require. Extremophils show us how narrow that view is. Life does not need sunlight. It does not need warmth. It does not even need oxygen in some cases. It needs only a foothold. Once it has that, it will spread, adapt, and flourish. The trenches are proof that life is less fragile than we imagined, more persistent, more inventive, and far less concerned with what we think is habitable. In this way, extremophils are not just organisms, they are reminders that our definitions are not the same as nature's, reminders that survival can take forms we would never predict, reminders that what we call extreme is often just another version of ordinary, seen from a different perspective. In the silence of the trenches, microbes, amphipods, and snailfish live lives as complete as ours, without ever knowing that the world above considers them impossible. So when we study them, we're not only studying the limits of biology, we're studying possibility. Possibility for Earth, for other worlds, and for our understanding of life itself. The role of extremophils is not simply to survive where nothing else can. It is to show us that survival is broader, stranger, and more flexible than we imagined. And as we descend deeper into the trenches carrying their lessons with us, we see that the story of life is not confined to comfort zones. It is written everywhere, even in the crushing dark, and perhaps far beyond our planet too. When we talk about the Hadal trenches, most of what we know comes not from nets or sensors lowered from ships, but from the few times humans and their machines have descended into that world themselves. It is one thing to imagine the trenches from maps and measurements, quite another to look through a small window and see the seafloor 11 kilometres below the surface. Exploration of the Hadal zone has always carried an air of daring, not only because of the hostile environment, but because of the enormous engineering challenges required to survive it. Each descent echoes with the courage of those who risked everything and the ingenuity of the machines that carried them. The first serious attempt to reach the deepest point came in 1960, when Jacques Piccard and Don Walsh boarded the bathyscaphe Trieste. At the time, even sending a person into the midnight zone was extraordinary. The Trieste was not sleek or futuristic. It was a massive vessel built around a single principle: survive the pressure. Its passenger sphere was a thick steel ball, suspended beneath a large float filled with gasoline to provide buoyancy. The sphere was barely big enough for 2 men to crouch inside, surrounded by meters of steel walls with only the smallest window. It was crude compared to today's submersibles, but it was enough. On January 23, 1960, the Trieste descended into the Mariana Trench, taking nearly 5 hours to reach the bottom. What Piccard and Walsh experienced remains one of the most remarkable feats in exploration. Through the tiny porthole, they saw sediment stir as the craft settled on the sea floor. They reported seeing shapes, possibly fish, possibly invertebrates, drifting in the light of their lamps. What mattered most was not the details, but the fact that they had been there at all, alive, at a place previously thought unreachable. When they resurfaced nearly 9 hours later, they had proven that the deepest point on Earth was not beyond human reach. The echoes of that dive still resonate, because in 1960, long before astronauts walked on the moon, 2 men had already visited the bottom of the ocean. For decades after, no one returned. The cost, the risk, and the limited technology kept the trenches out of reach. Instead, remotely operated vehicles and camera landers became the primary tools. These machines revealed amphipods, snailfish, and microbial mats, sending back images without risking human life. But the dream of returning remained. It was not until 2012 that another person descended to the very bottom. This time, it was filmmaker James Cameron, piloting a submersible called the Deep Sea Challenger. Unlike the Trieste, this craft was built with modern materials, using a vertical design to slip through the water more efficiently. Cameron's dive lasted about 3 hours on the seafloor, during which he filmed and collected samples. For the first time, the Hadal trenches were not just visited but documented in detail by a human eye. Cameron described the experience as otherworldly. Looking out from the sphere, he saw a barren plain of sediment, ripples carved by currents, and occasional shapes drifting past. The silence, the weight, the sense of being in a place untouched by life above, it left a lasting impression. He spoke of feeling both isolated and deeply connected, aware that he was seeing something few humans ever would. His dive reignited interest in trench exploration, proving that with modern engineering these places could be reached more safely and more often. Since then, other explorers have followed. Victor Vescovo, an adventurer and retired naval officer, undertook a series of dives known as the 5 Deeps Expedition, aiming to reach the deepest points of all the world's oceans. Between 2018 and 2019, his submersible, the Limiting Factor, descended repeatedly into trenches including the Mariana, the Puerto Rico, the Java, and the Tonga. Each dive added to the map of human experience in the Hadal zone, bringing back not only footage and samples, but the reassurance that these depths were not one-time curiosities, but places we could study regularly. The technology of these submersibles is extraordinary in itself. The pressure at the bottom of the trenches is enough to crush steel, so the passenger compartments are spheres, the strongest shape for distributing force. Windows are not glass, but thick panes of fused quartz, transparent yet strong enough to resist implosion. Every seam, every weld, every bolt must be flawless, because even a pinhole leak would mean instant disaster. Systems are redundant, power supplies carefully balanced, life support systems designed to last far longer than the intended dive. There is no margin for error in the Hadal zone. Success is a matter of precision, discipline, and trust in engineering. And yet, for all the risk, the reward is profound. Each descent reveals a world few have seen. Amphipods swarming to bait, snailfish hovering gently, sediments rippling under the lights. In some dives, entirely new species have been discovered. Microbes collected from the seafloor have shown novel adaptations to pressure, chemistry, and energy sources. These discoveries remind us that the Hadal trenches are not empty but vibrant, and that the more we look, the more we will find. For the explorers themselves, there is also something deeply human in these dives. To sit inside a sphere surrounded by meters of steel, descending into blackness for hours on end, requires not only bravery but a kind of curiosity that outweighs fear. Picard, Walsh, Cameron, Vescovo all describe the same feeling. Awe at the scale, at the silence, at the knowledge that they are seeing something hidden from almost everyone else who has ever lived. Their voices, recorded after resurfacing, carry the weight of experience that cannot be replicated by cameras alone. The echoes of exploration linger because these dives are not just about science. They're about pushing boundaries, about proving that even the most inaccessible places on Earth are within reach if we have the will to go there. They connect the trenches to the history of exploration more broadly, alongside the first steps on Everest, the first flights into space, the first footprints on the moon. Each was impossible until it was done. Each reshaped our understanding of what humans could achieve. But unlike space, the trenches remain close. They're on our own planet, beneath seas that touch our shores. To know that such alien environments exist not in another solar system but here, on Earth, adds to their allure. Each dive is not only a journey into the deep, but a reminder that mystery does not require distance. It requires courage and the technology to follow curiosity wherever it leads. Today, submersibles continue to visit the trenches, some piloted, many unmanned, each one extending the reach of human observation. The data they bring back, videos, samples, measurements, feeds into science, expanding our knowledge of geology, biology, and chemistry at the extremes. But beyond the science, they continue the tradition of exploration. They remind us that even in an age of satellites and global maps, there are still places on Earth where the unknown waits in silence, and where descending into the dark is still an act of bravery. The Hadal Zone is a world that does not welcome us. It crushes, silences, and isolates. Yet through engineering and determination, we have entered it, if only briefly, and glimpsed its secrets. The echoes of those explorations are not only in the data collected, but in the human stories told afterward. Stories of pressure creaking against steel, of darkness swallowing light, of strange creatures drifting into view, of awe so profound that words barely capture it. These echoes remind us that exploration is not just about reaching new places. It is about discovering that even in the most hostile environments, curiosity can still find a way to survive. What is it that keeps drawing us back to the deepest parts of the sea? We know the risks. We know the expense. We know that most people will never see these places directly, that even those who descend will spend only a handful of hours at the bottom. And yet, the pull remains. Human curiosity has always been drawn to the edges of the known world, to the peaks of mountains, to the far reaches of deserts, to the expanse of space. The trenches belong to that same story. They are part of the map that is still unfinished, and for reasons we cannot easily explain, we are compelled to fill in the blanks. Part of this pull comes from mystery itself. When we stand on the shore and look out at the ocean, we are aware, however faintly, that beneath those waves lies something vast and unseen. The surface is familiar, but the depths are not. That gap between what we know and what we don't is what sparks curiosity. The trenches represent the farthest extension of that unknown, places that seem more distant than the moon even though they are right here on Earth. For many, that alone is reason enough. To know that there are valleys deeper than mountains at all, filled with creatures no one has ever seen, is an invitation we cannot resist. Curiosity is not only about discovery, but about perspective. Each time we peer into the trenches, we are reminded that the world is larger and stranger than our daily lives suggest. We live in cities, surrounded by technology, convinced that the planet has been charted and explained. But the Hadal zone proves otherwise. It humbles us. It tells us that our knowledge is incomplete, that mystery is not gone but waiting beneath our feet. Curiosity thrives in humility. It grows strongest when we realise how much we still don't know. There's also something deeply human about seeking what we cannot see. Our species has always been restless. We crossed plains, sailed oceans, climbed peaks, and launched into the sky. Each step was taken not because it was safe or necessary, but because it was possible. The trenches continue that legacy. To descend into darkness with no guarantee of what you will find is to embody the same drive that carried early humans across continents or astronauts beyond the atmosphere. It is the continuation of a story that began long before we had the words to record it. Psychologists sometimes describe curiosity as an instinct tied to survival. To learn is to prepare, to explore is to find resources or avoid danger. But curiosity goes beyond necessity. We explore not only what is useful, but what is unknown simply for the sake of knowing. The trenches have no immediate benefit to most of us. They're not filled with resources we can easily extract or landscapes we can inhabit. Yet we still send machines and people into them. The drive here is not survival, but wonder. That is what makes it human. There is also the allure of contrast. On the surface, life is shaped by light, warmth, and abundance. The trenches are the opposite: dark, cold, scarce, crushing. By seeking them, we confront the limits of our own world, testing how far life can stretch. Each new discovery in the Hadal zone changes our understanding of biology, and by extension our understanding of ourselves. When we find microbes living only under pressure, or fish thriving where bones should fail, we learn not just about them, but about the possibilities of life everywhere. Curiosity is not satisfied with what is comfortable. It asks what lies beyond comfort, what survives when the rules are rewritten. Stories also play a role. From the earliest myths, the ocean has been a place of mystery. Ancient cultures filled it with monsters and gods, beings that lived in darkness where humans could not go. The trenches are the modern version of that same imagination. We may no longer believe in sea serpents, but we still project awe onto the unknown. Each expedition into the Hadal zone is both a scientific mission and a narrative. Brave explorers, dangerous environments, hidden worlds. The human mind has always been drawn to stories of descent, and the trenches provide one of the purest forms of that tale. There is another reason we keep seeking what we cannot see, because it challenges our assumptions. The trenches force us to ask questions about the limits of life, about the role of Earth systems, about the possibility of alien worlds. Every time we assume that nothing could survive, we are proven wrong. Every time we think we understand the rules, they change. Curiosity thrives on challenge. It is fueled not by answers that confirm what we know, but by discoveries that overturn it. The Hadal trenches deliver those challenges in abundance. Even for those who will never dive, the act of exploration resonates. Watching footage from submersibles, reading reports from expeditions, hearing the voices of those who descended, it connects us to the experience. Curiosity is contagious. We may never peer through a porthole at the seafloor, but knowing that someone has, and that they saw creatures alive where we thought there was only emptiness, sparks our own sense of wonder. The trenches remind us that exploration is not about personal experience alone. It is a shared story, one that enriches us all. And perhaps the simplest reason of all is that the unknown will always call. To stand before it and turn away would be to deny something fundamental in ourselves. Curiosity is not comfortable, but it is essential. It drives us into deserts, up mountains, across space, and into the deepest valleys of the ocean. The Hadal zone is one of the last places where the unknown still stretches wide. As long as it remains, so will our need to seek it, even if we cannot see it, even if it defies us, even if it shows us how small we really are. When we speak of the trenches, we usually describe them in terms of science, the depth, the pressure, the creatures, the chemistry. But there is another dimension that is harder to measure yet just as real, and that is the way they shape our minds. Depth does not only press on the steel walls of submersibles or the bones of fish, it presses on our imagination. The Hadal zone is as much a psychological frontier as a physical one, and what it represents to us often says as much about ourselves as it does about the ocean. For most of us, the deepest we have ever been underwater is perhaps a swimming pool or a shallow dive at the beach. Even at a few meters there is a sense of strangeness. The light dims, sound changes, and the weight of water makes us aware of how out of place we are. Multiply that feeling thousands of times, and you begin to understand why the trenches are so difficult to picture. They stretch far beyond the reach of our senses, and in that gap the imagination takes over. We fill the dark with creatures, with fears, with mysteries, and with symbols. The abyss becomes more than a location. It becomes an idea. In literature and myth, depth has always carried psychological weight. Ancient stories spoke of underworlds beneath the earth, places where souls journeyed after death. Oceans were imagined as realms of gods and monsters, beyond human reach. Even today, when science has explained much of the world, the idea of descending into a trench carries echoes of those older tales. It feels like entering another domain, one that is not ours, one that demands respect, awe, and sometimes fear. The fear of depth is not irrational. To the human mind, endless darkness, silence, and crushing weight all trigger primal responses. We are creatures of light and air. The abyss is the opposite of what we need to survive. When we imagine it, we project not only curiosity but also dread. The thought of sinking into blackness, of being surrounded by pressure and silence, of knowing that rescue is impossible. These ideas resonate with our deepest fears of being lost, alone, or consumed. The trenches become metaphors for anxiety, for depression, for the unknown parts of our own minds. But depth also inspires awe. There is a psychological pull toward what is vast and incomprehensible, what some call the sublime. Standing before a mountain, staring at the stars, or imagining the Hadal trenches all create this effect. It is not only fear, but wonder, a sense of being small in the face of something larger than ourselves. That mixture, fear and awe together, is perhaps the most accurate way to describe how the trenches shape imagination. They terrify us and attract us at the same time. We want to look, even when looking unsettles us. Explorers who have descended into the trenches often describe this tension. James Cameron spoke of feeling deeply isolated yet profoundly connected, aware that he was in a place both alien and familiar. Don Walsh and Jacques Picard recalled the strangeness of looking out into total blackness, broken only by their lights, and realizing that beyond that tiny circle was endless dark. Their words echo not just the physical experience but the psychological one. To be there is to feel both insignificance and privilege, to know you are far from home yet still on Earth. Even for those who never descend, the psychological impact is real. Images of the trenches stir the imagination in ways that few other places do. A photograph of a snailfish, translucent and hovering, can evoke wonder in someone who has never left the surface. A diagram showing the depth compared to Mount Everest can shock the mind into realizing how immense the oceans are. The abyss shapes imagination not only by being seen, but by being imagined, by existing as a reminder of how much lies beyond our reach. There is also something about downward journeys specifically. Going up, into the sky, into space, feels like striving, like progress. Going down feels different. It feels like confrontation, like entering hidden spaces we were not meant to see. The ecological abyss is not only about depth of water, but depth of thought. To descend is to go inward, to confront what lies beneath the surface. That is why the trenches resonate with metaphors of the subconscious, of hidden fears, of the parts of ourselves we rarely face. They are the literal and symbolic underworld of our planet, and the human mind cannot help but connect them with its own underworlds. But imagination does not stop at fear. It also invents. For centuries before we had evidence, people imagined monsters lurking in the deep, krakens, leviathans, serpents. These creatures were not real, but they filled the psychological space created by the unknown. Today we know the trenches contain amphipods and snailfish, not dragons. And yet the fascination remains, because the real creatures are no less strange. They may not be monsters, but their translucence, their adaptations, their fragile strength, all of it feels alien. In a sense, reality has caught up with imagination, showing us that we were not wrong to think the abyss held the bizarre. We just underestimated what form it would take. The psychological abyss is also about possibility. Each time we look at the trenches, we are reminded that life can exist in places we once thought impossible. That thought expands beyond the ocean, into our search for life elsewhere. The trenches feed our imagination not only of Earth but of other worlds, oceans beneath ice, alien ecosystems hidden in dark valleys. The idea that we are not alone, that life is broader than we thought, is one of the most powerful psychological impacts of the deep. It makes us dream not only of what is beneath our seas, but of what may be beneath others. In the end, the trenches are not just physical locations, they are mirrors. They reflect our fears of darkness and isolation, our awe of the vast and unknown, our drive to explore, and our willingness to project meaning into places we cannot see. The psychological abyss is part of what makes the Hadal zone so compelling. It is not only the creatures or the pressure or the geology, it is what those things do to our imagination, how they pull at the threads of curiosity and fear woven into the human mind. The depths of the ocean will always be both real and symbolic. Real, in that they exist as places we can measure, visit, and study. Symbolic, in that they represent what is hidden, what is mysterious, what is beyond the reach of ordinary life. This dual nature is why they matter, why they continue to shape thought and inspire exploration. The trenches are not just valleys in the sea floor, they are valleys in our imagination, carved as deeply into our minds as they are into the planet itself. When we peer into the Hadal trenches, we are not only looking into the ocean. In many ways, we are looking into a mirror. The conditions there are so different from what we know, yet the life that persists under those conditions reflects truths about life's resilience, its boundaries, and its possibilities. The trenches are not just hidden landscapes. They're reminders of what life can endure, of where it can appear, and of how fragile our own assumptions about habitability truly are. The first reflection the Hadal zone gives us is that life's limits are not where we once believed. For centuries, humans drew lines around what was possible. Nothing could survive without sunlight, we thought. Nothing could survive under such crushing weight. Nothing could thrive in the cold, in the dark, in the scarcity of the deep. Yet at every turn the trenches prove us wrong. Amphipods scuttle across the bottom. Snailfish hover with ease. Microbes metabolize minerals inside sediments. Life is not absent. It is abundant. The mirror here shows us that our lines were never nature's lines. They were only the limits of our imagination. Another reflection is the way life achieves resilience. On the surface, survival often means resistance, building hard shells, growing thick skins, standing firm against threats. In the trenches, survival means something else. It means softness, transparency, delicacy. It means proteins stabilized by molecules we do not need, membranes made fluid by chemistry we cannot imagine using. Life here survives not by resisting the environment, but by embracing it so completely that it becomes inseparable from it. This tells us that resilience is not a single trait. It is relative. What looks fragile to us is strength under pressure. What looks alien is simply natural in a different world. The mirror of the Hadal zone reflects back the diversity of strategies that life can invent when faced with challenge. The trenches also remind us of life's patience. Food does not arrive in steady abundance. It drifts down in the form of marine snow, or arrives suddenly in the fall of a fish or whale. To live here is to wait, sometimes for days, sometimes for months, surviving on little until opportunity appears. Life in the trenches is slow, deliberate, conserving energy, storing what it can. In this way, the mirror shows us another truth. Survival is not always about constant activity or rapid growth. Sometimes it is about endurance, about making the most of what comes, about stretching resources as far as possible. That lesson is as relevant to our own world as it is to the trenches. There is also a reflection about connection. The trenches feel isolated, far below, cut off from light and warmth. Yet they depend entirely on what falls from above. Marine snow, sinking fish, whale carcasses, all of it comes from the surface. The deepest valleys of the ocean are tied to the shallowest layers in ways that cannot be broken. This tells us something fundamental about life, that no ecosystem exists alone. Even the most extreme habitats are connected to larger systems, drawing energy from elsewhere, shaping global cycles of carbon and nutrients. The mirror here shows us that life is not separate parts, but one network, stretched across depths and distances, each piece depending on others. The Hadal zone also reflects possibility beyond Earth. If life can survive under pressure that crushes steel, in darkness that has lasted millions of years, feeding only on chemical traces and falling scraps, then perhaps life can also survive on icy moons beneath alien seas, inside rocks buried deep underground. The trenches do not just expand our view of Earth, they expand our view of the universe. They show us that habitability is broader than we thought, that the conditions for life are not limited to a narrow strip of warmth and light. The mirror reflects not only what exists here, but what might exist elsewhere, waiting in other abysses we have not yet reached. Yet the trenches also remind us of fragility. While the creatures of the Hadal zone are perfectly adapted to their environment, they cannot survive outside it. Bring them to the surface and they die. Expose them to our pressures and they collapse. Their resilience is real, but it is specific. This tells us that survival is always conditional. Life adapts to its environment, but that environment defines what it can or cannot do. In this way, the trenches reflect back a truth about ourselves. We too are fragile outside our comfort zones. We depend on air, on pressure, on temperature within narrow limits. To imagine surviving in the Hadal zone without technology is as impossible as imagining its creatures surviving on the surface. Life is always strong in its own world, and always fragile outside it. This duality, resilience and fragility, strength and limitation, is one of the clearest lessons the trenches give us. They remind us not to confuse our perspective with universal truth. What we call extreme may not be extreme at all. What we call impossible may simply be unfamiliar. Life is not fragile in itself. It is fragile only when misplaced. In its proper setting, it is unstoppable. The trenches mirror something else too, our own curiosity. The very fact that we are drawn to them, that we send machines and people into their depths, tells us something about human nature. We are not satisfied with surfaces. We want to see what lies below, beyond, behind. We want to know if there are limits, and if so, where they lie. The Hadal zone reflects this drive back at us, because each time we look, it answers with another challenge, another surprise, another push against what we thought we knew. Our curiosity is as much a part of life's resilience as the chemistry of microbes or the bones of snailfish. It is our adaptation to mystery. Perhaps the most important reflection the trenches offer is that life is not rare but resourceful. Wherever there is a crack, a pocket, a possibility, life finds it. In boiling vents, in frozen ice, in desert sands, and in the crushing dark of the Hadal zone, life adapts. It does not cling to one formula but invents new ones, endlessly varied, endlessly inventive. The trenches are a reminder that life is not a fragile accident but a force, one that bends and twists itself to fit the conditions it finds. In this way, the trenches are not only mirrors of life's limits but of life's creativity. When we study the Hadal zone, we learn not only about strange fish or rare microbes. We learn about what it means to be alive, about how survival works under conditions we never imagined, about how narrow our own view has been. The mirror is not always comfortable. It shows us our fragility as well as life's resilience, our assumptions as well as nature's inventions. But it is valuable, because in reflecting back at us, it expands our understanding. It tells us that the story of life is larger, stranger, and more flexible than we thought, and that we are only one small version of it. When we look at the creatures that thrive in the trenches, the question naturally arises, could we ever belong there too? Not as brief visitors sealed inside titanium spheres, but as living beings able to endure the same conditions as amphipods or snailfish. Could humans adapt to a world of crushing pressure, permanent darkness, and scarce food? Or is our presence in the Hadal zone destined to remain temporary, dependent on machines? The first obstacle is pressure. At the surface, we live under the weight of one atmosphere. At the bottom of the Mariana Trench, the pressure is over 1,000 atmospheres, the equivalent of an entire mountain pressing on every part of your body. For the snailfish, this is normal. Its proteins are stabilized by special molecules, its tissues flexible enough to compress without breaking. For us, it would be instant destruction. Lungs would collapse, bones would shatter, blood vessels would burst. Our physiology is tuned to the narrow band of pressures where we evolved. To belong in the trenches, our very biology would have to be rewritten. Then there is temperature. The waters of the Hadal zone hover near freezing. For us, unprotected, that would mean hypothermia within minutes. For trench organisms, it is simply background. Their metabolisms run slowly. Their enzymes adapted to function at low temperatures. Again, what is deadly for us is normal for them. Darkness, too, would challenge us. We depend heavily on sight. In the trenches, vision is nearly useless. To live there, we would need other senses, detecting vibration, chemical trails, faint glimmers of bioluminescence. Our eyes, so central to our lives on the surface, would be irrelevant in the deep. Food is another barrier. Life in the trenches depends on what falls from above. Marine snow provides a steady trickle, punctuated by rare windfalls like whale carcasses. For humans, with our large energy demands, such a diet would be insufficient. We would starve long before finding enough scraps to survive. To belong in the trenches, our bodies would need slower metabolisms, greater efficiency, and the ability to endure long periods without eating. In essence, we would have to become different animals entirely. Technology allows us to visit, but only briefly. Submersibles shield us from pressure, provide warmth, and carry food and oxygen. Yet these are bubbles of our world carried into another, not true belonging. When we step out of the submersible, even in imagination, we see how utterly alien the Hadal zone is to our biology. To ask if we could ever belong there is to ask whether we could cease to be what we are and become something else. And yet, the question is worth asking, because it makes us reflect on what belonging means. Do we belong only in the narrow range of conditions that shaped us? Or can belonging also mean the ability to extend ourselves with tools? Birds do not belong underwater, yet some dive and swim. Humans do not belong in space, yet we have walked on the moon. Perhaps belonging is not only about physiology, but about will and adaptation. If so, then in a sense we already do belong in the trenches, because we have gone there, however briefly, and returned with knowledge. Still, there is a difference between visiting and living. The creatures of the trenches are not visitors. They are residents, adapted so fully that our world would kill them. To imagine humans belonging there in the same way is to imagine a future where our biology is changed as radically as theirs. Could that ever happen? Evolution is powerful, but it works slowly, shaped by survival across countless generations. For humans to adapt naturally, we would have to live in the trenches for thousands, perhaps millions of years, long enough for our bodies to change completely. That seems unlikely. More probable is that if we ever wish to stay, it would be through technology merged with biology, engineered bodies, artificial adaptations, machines worn not as suits, but as parts of ourselves. Even then, the question remains whether the Hadal zone is a place worth belonging to. For the creatures there, it is home. For us, it is foreign, hostile, a place of fascination but not comfort. Belonging is not only about survival, but about meaning. We are tied to light, to land, to warmth. The trenches may inspire us, but they are not our natural home. Perhaps that is why we're so drawn to them. They are reminders that not all places need to be inhabited by us, that some worlds are best left to others, and yet even if we never live there, the trenches shape us in other ways. They expand our imagination, stretch our definitions of habitability, and remind us of life's flexibility. In that sense, they become part of our belonging, not as physical habitats, but as intellectual ones. They are places we visit with thought, with science, with curiosity, even if not with our bodies. The question of survival there is less about whether we could live in the trenches and more about whether we can learn from them, whether their lessons about resilience, patience, and adaptation can inform how we live on the surface. So could we ever belong here? The honest answer is no, not as we are. Our bodies are not built for pressure, cold, darkness, or scarcity. But the deeper truth is that we do not need to belong in every place to learn from it. The Hadal zone is a world designed for others, and in that difference lies its value. It shows us that life takes many forms, that survival is relative, and that our way of being is only one among countless possibilities. To see that reflected back at us is to understand belonging in a broader sense. We may not belong in the trenches physically, but they belong in our story, in our understanding of what it means to live on this planet. We began on the surface, where light pours down and the ocean looks endless but familiar. Then we followed the descent, past the zones where sunlight fades, through the twilight, into the midnight, and deeper still into the trenches. Along the way, we found life where none was expected, survival strategies that seemed impossible until we saw them, and reminders that the world is larger and stranger than we usually allow ourselves to imagine. Now, as we return toward the surface, it is worth reflecting on what the journey means, not only for science but for the way we see life itself. The trenches are often described in terms of their hostility, pressure, cold, darkness, scarcity. But the creatures that live there do not see hostility. They see home. For the amphipod, the whalefall is a banquet. For the snailfish, the seafloor is hunting ground. For the microbes in sediment, the crushing weight is the only condition under which their chemistry works. To them, there is no harshness, no extremity. There is only life lived as naturally as ours is on the surface. In reflecting on this, we see how much of our idea of difficulty is relative. The trenches are unlivable for us, but for their residents they are perfectly normal. And this is perhaps the most important truth the Hadal zone leaves us with. Life is adaptable. It does not cling to one narrow set of rules. It bends, stretches, invents, and persists. Wherever energy can be captured, wherever conditions can be tolerated, life finds a way. This does not make the trenches less strange. It makes them more extraordinary, because they reveal just how broad the possibilities of survival really are. We also saw how interconnected the planet is. The deepest valleys are not isolated voids but extensions of the surface. Marine snow drifts down in an unbroken chain. Whale carcasses become ecosystems in the deep. Carbon cycles continue in silence beneath kilometres of water. The trenches may seem distant, but they are tied to the world we know, influencing climate, recycling nutrients, shaping Earth's systems in ways invisible to us. To look at them is to see connection, the reminder that no part of the biosphere is truly separate. The Hadal trenches also reflect our own nature back at us. They show us curiosity at work, the need to descend even when it is dangerous, even when it is costly, even when it reveals things that unsettle us. The echoes of Picard, Walsh, Cameron and Vescovo are not only about reaching the bottom, but about the human impulse to see what lies beyond. Their stories are part of the same pattern that carried us to the moon, that will carry us further still. The trenches remind us that exploration does not require distance. Sometimes the greatest unknowns lie just beneath our own seas. There is humility in the trenches as well. The creatures we call fragile are not fragile in their world. We are. The environments we call extreme are not extreme in themselves. They are extreme only compared to us. This reflection is valuable because it broadens our understanding. It tells us that our perspective is not the measure of what life is capable of. It reminds us that resilience comes in many forms and that strength can look like delicacy if we are viewing it from the wrong angle. And then there is the way the trenches feed imagination. Depth has always been a metaphor for mystery, for danger, for the unknown parts of the self. The Hadal zone continues that tradition, giving shape to our fascination with darkness and our fear of what lies beyond our senses. But unlike myths and legends, this abyss is real, filled not with imagined monsters but with real animals stranger than anything we could invent. That tension between myth and reality, between fear and discovery, is part of what makes the trenches so powerful in shaping how we think. As we rise back toward the surface, the journey upward is not only physical but symbolic. We carry with us the images of amphipods swarming, snailfish drifting, microbes shaping chemistry in silence, submersibles creaking as they descend, explorers staring through small windows into blackness. We carry the reminder that the Earth is not fully known, that even in the 21st century there are frontiers untouched. We carry the lesson that life is more flexible than we imagined, that it finds ways not only to survive but to flourish in conditions we would call impossible. And perhaps most of all, we carry the quiet realization that mystery is not gone from the world. It is not confined to distant planets or far-off galaxies. It is here, beneath the waves, waiting in trenches deeper than mountains are tall. The Hadal zone shows us that we do not need to look far to find the unknown. We only need to be willing to look where light does not reach. So as we return to the surface, to air and sunlight and the familiar rhythms of life above, the trenches remain below, unchanged by our brief visits, patient in their silence. They will continue as they have for millions of years, filled with creatures that know nothing of us, thriving in the dark. And in that there is comfort. Not everything must be touched. Not everything must be tamed. Some mysteries can remain, shaping our imagination simply by existing. The Hadal zone is not only a place we visit in submersibles or through cameras, it is a place we visit in thought, in curiosity, in wonder. And though we cannot live there, though we cannot truly belong, it belongs to us in another way. It belongs in our story of exploration, in our understanding of life, in our reminder that the planet is still larger, deeper, and stranger than we thought. That is the gift of the trenches, to show us what lies beyond sight, and to leave us with the sense that there will always be more to discover.